A warm good morning to one and all. The expert in anything was once a beginner, Helen Hayes. As we step into the final day of our 1 week FDP, we reflect on the wealth of knowledge and skills gained throughout this enriching journey. Today's first session promises to build further on that foundation, focusing on incident response using log analysis through Splunk. Let's stay engaged and make the most of this concluding day of learning and growth. Let me give a brief introduction about Dr. Lavanya, who will be leading today's session. Dr. Lavanya Sitlapalli is currently working as an assistant professor in the Department of CSE Cybersecurity, IIIT Kottayam. She pursued her PhD degree from the NIT Tiruchirappalli, Tamil Nadu. She completed her master's in technology and master in computer applications from JNTU Kakinada and Bachelor in Science from Acharya Nagarjuna University. Her research interests focuses on information security, biometric security, blockchain technology, big data analytics, computer vision, and natural language processing. She published her research in several high impact factor reputed journals. She also organized and co organized several workshops and conferences. She co organized and handled training sessions in prestigious short term training program for Kerala Police in cybersecurity aspects. We welcome you, ma'am. Over to you.
Yeah, am I audible to online students? Yeah. Mhm. I didn't. Yeah. So we are discussing about incident response. Okay. So incident response through log analysis. So first of all, I would like to ask you some questions. What you understand or what your guess about incident response? After hearing this topic, uh, Do you have any guesses? After attack happens. Okay. If some attack is happened, so how we are going to respond? Let us suppose someone brute forced into my system. Okay. I have a laptop or I have a system connected in a network. Okay. That's been brute forced. Okay. And someone entered into my system and someone's theft my secret files. Okay. Let us assume that this data breach happened. Some data breach happened. Okay. That is one kind of attack that happened. Okay. That is one incident. So now response. So how we are going to respond? Before respond, how we come to know about something happened in your system. So that is the main thing here. How we can come to know that something has happened? Let us suppose someone silently, remotely entered into my system through the network. They breached my files. How I can know? Okay. If, see, breach happened will not give you any kind of abnormal activities in your system. If any breach happened, it won't leave any traces. It won't leave traces in the sense active traces, visible traces. Means your system responds normally, even though some breaches happened. And this kind of breach happened. If any some virus is infected, if some malware is affected into your system, that can be analyzed or that can be identified, detected by your whatever your antivirus systems. But not these kind of actions. Someone remotely accessed, successfully log into your mission, breached some files, will not detect by your antivirus. If any malware pattern is there, virus pattern is there, any kind of pattern is there, then only it can be identified with your antivirus software. Now, answer. That is where log analysis. So what is a log? Do I need to explain what is a log? No, right? Everyone knows what is a log. How many of you know that your Windows operating system is logging everything that is happening on your mission? How many of you know? Just raise your hands. Okay. Whatever, starting from your login, what files you are like accessing, whether you are reading, writing, copying, deleting the files, whatever it is, everything is being logged by any of your OS, not only Windows. It can be either Windows, Linux, some other thing. And whatever the tools that you are using, you might have seen so many tools so far, right? Whatever the tools, each and every tool log their activities. Log their activities. For what purpose? What is the importance of logging? Through them only, we can come to know what is happening in our mission or through our tool or something else. It can be HTTP logs. It can be your email logs. It can be, your emails also can be logged. So what is the activity, from which IP to which IP this email is being sent, everything will be logged. Okay. And if you take your operating system also, each and every operating system will have its own logging mechanism. So whatever the activity that is happening will be logged. Okay. Now, what is the importance of this log analysis, particularly coming to this Splunk, or some more tools are there like your Datadog for this particularly log analysis? What exactly exactly what is the need of this log analysis and where this particular concept is applying more. One is in defense systems. Defense systems in the sense, let us suppose in criminal investigation kind of things. And one more thing is in your software environments. These two areas are widely using this log analysis tools. So let us see in software what is happening. So I'm not going to present any slides. For sure, I'll give you hands-on. Okay, full to full hands-on. So first of all, we have to know what is the flow of this log analysis. Okay, and what is the applications of this log analysis. Through log analysis, what we can do. We have a log files. Have you ever seen any log file? How the log file will be? If you don't, I have already shared with you some sample log file. Just open it. That is database tool, MySQL. I hope MySQL tool everyone knows, right? Your MySQL tool also records some logs, whatever the activities it is doing. Okay, bin logs will be there, error logs will be there. Particularly, I have taken error logs. Error logs can identify if some brute force attack is happened or if any firewall, firewall denied things are there, incidents are there. So all this will be logged in your error file. So I have given you some error file, which is having all these logs. So how your log will be? Your log is just a text without mentioning about each and every component. Is this visible? So this is your sample log file, error log file. Okay. What it contains? Just some random statements about each and every activity that happened in your tool. Okay. So can you say what is this? What is this? Let us suppose if I ask what is this? What is this? That is
நான் அதை வச்சுதான் நேத்திக்கு கிரேட் கால்குலேட் பண்ணோம்.
timestamp that everyone can understand by seeing this. Now, what is this? Then what is this number? No. Okay. Okay. Then what is this? Leave it. What is this? Activity. Activity. So from this log information, you can hardly identify 2 or 3 components from that log statement, right? When you will get to know about each and every component is if you are having subject knowledge of that particular tool that you are using. Okay. So along with log analysis, using some particular tools, Splunk or Stack or something else, you need the subject knowledge of in that particular thing, in that particular attack, or in that particular tool on which you are analyzing the attack. Okay. So this is nothing but the event ID. So my 010116, some event ID. This particular event ID is telling you that my SQL tool is started. When your MySQL tools get started, This is the standard event ID recorded every time. And this is related to the server activity, not InnoDB engine activity. It is server activity. Okay. And this is whether it is an alert, whether it is a system, whether it is a note, it is system related. Starting is something related to the system. It is not an alert. It is not a message. It is not a note. Okay. So that is what this log tell you about each and everything. Before you do an analysis, you should have a subject knowledge on that. Okay. Now, so, okay, keep this logs aside. Then we have the logs, but we don't know what is what. We don't know the information about what is what. Now, how I can tell the tool, how I can ingest all these tools into the tool, ingest all these logs into the tool. How a tool can understand what is what. This is timestamp and this is event ID. So based on this, I can do the analysis. Is in between log parsers will be there. Log parser is nothing but so parsing and structuring is nothing but unstructured logs will be structured properly as per the component. If it is timestamp, timestamp. If it is event ID, event ID. Each and every tool, including Splunk, Elk Stack, having this knowledge. If you say what is the source type, it will divide that particular log into the structured format. That is what we call as log parsing. Okay, log parsing and structuring. Once the logs are parsed, once the logs are loaded into your tool, usually your log analysis tools will have three types. One is this one, parsing part. So one component will take care of this parsing part, structuring part. Then the other tier is server, where you can retain all your logs. The another tool, which is very important tool, is monitoring tool, visualization tool. Okay, Splunk tool is all together. It is having parsing itself, and it is having server itself, and it is having this visualizations itself, monitoring itself. Okay, and through this log analysis, what we can do? Through this log analysis, so I'll tell you where we are using. I told you two applications, right? One is for police officials for investigation side, and the another one is for software environments. I'm taking these two applications. Okay. Now, when it comes to police people, what they will do? Let us suppose, as I told you, some incident has happened. Okay. Someone unofficially logged into your mission and they breached your file. Now you reported to some cyber police. Okay. Now, how they will identify from your mission? So before that, so many prerequisites are there that should be enabled. Otherwise, no one can do anything. Okay. What they can do is, at that point, how they can catch the defaulters, or how they can catch the attackers. We need to find, if it is through internet, how we have to do? We have to identify the IP address of that person. Remotely he joined, right? Remotely he connected to our mission unofficially, right? If we can get the IP address from which this connection is established, then that is enough, right? We'll get the public IP. Through that, we can get into the private network, and if possible, we can get the MAC and we can identify the attacker. But before that, how this IP address can be identified? What usually can be done is, we can go through the logs And I'll tell you what is the drawbacks also. Okay. So one thing is we can go through the logs of your operating system, and we can, I'll also tell you different events, what can happen. So finally, through log analysis, we can identify the IP address who connected remotely to my system. That's fine. This is done through searching process. Searching process. We have logs, and thousands and thousands of logs are there. Okay, manually searching all these things is not possible. So some log analysis tool is required, which will provide you easy searching through all your logs. Okay, then another scenario, another application, what I told you, as software environment. Okay, what usually the software people or software companies do? Any of you from company? Okay. So what the software companies will do? They'll maintain a central system. They'll maintain a central system. They will give access to all the employees to access their resources. Okay. They don't share resources. Clients don't keep all the resources in their own mission. Everyone will be given with one mission. Okay. They all maintain as a network. One central mission will be there. All resources will be kept in that central mission, and clients will be given with some credentials. Through that credentials, they can access the resources from that central mission. So this is what happens in software companies, right? Now, if anyone, whether it is insider or outsider, like some attacker, what they can do is they can compromise some missions. Okay, through that mission, they can access the central mission. They can collapse or crash the entire thing. It is possible. Okay, now, of course, they maintain several servers and load balancing things will be there. If one server get failed or if one server get crashed, the load will balance it to other systems and the things will happen, right? But how they can get to know about something happened to their server? So most of the software companies are using Splunk. Actually, I'm teaching to MTech working professionals in the sense, the software engineers from different companies. So when I'm dealing with them about this database security concepts, they told me multiple times that they are using Splunk. Splunk, for what purpose? It is not for searching purpose there or reporting purpose there. For police people, the purpose is for searching and reporting. But for in software environments, if I want to know that something happened in my system, immediate alert I should get. I should get to know, and I should take the mitigations immediately, like load balancing things. How I can get to know? One can get the alerts only if we continuously monitoring our missions. Otherwise, it is not possible, right? So you have to continuously monitor through all the missions or through all the servers. If some malicious thing is happened, I should get to know about that malicious activity through some channel. So the beauty in the Splunk tool is Splunk tool can be connected to your mobiles. There is a facility, and if some malicious activities happen in your servers or in your missions, you will get a notification to your mobile. Of course, subscriptions are there, okay, but the facility is available with Splunk through Splunk Secure Gateway. Okay. So in between, I missed something. That is how this logs will be parsed. Logs from this normal textual format, they will be parsed to JSON documents. Okay. So I hope there is no need of explaining about JSON documents. I know you have a knowledge of JSON documents, right? So structure format followed by this Splunk or elk stack, all these things is the JSON document format. Okay. Now, so how many of you ready with your Splunk tool installed in your missions? Splunk service is installed successfully, right? Now, I'll tell you both scenarios. One is searching and reporting and visualization as well. And the another one is continuously monitoring and alerting. Okay. Let us see both. Okay. So you installed Splunk, right? Just open your Splunk from menu. Splunk Enterprise 9.4.2. This is the version you installed, right? Is it so? Is it Splunk 9.4.2? Because some like GUI is different from version to version. Otherwise, all this things are same. But when I am demonstrating, if you go with another version, some GUI components will be different. If you go with another version also, I'll tell you separately how to deal with that. Okay. Open your Splunk Enterprise. You might have given your credentials, right? So you might have given your credentials when you are installing your Splunk. Have you? Right? Just open, go with your credentials. So credentials that whatever you have used when you are installing or when you are downloading the Splunk.
No, ma'am, it's already installed in the machine. We don't know who installed it. And
Oh, it is already installed.
yes, ma'am.
Shenaf, is that installed by you? Splunk credentials.
Credential password. Listen and password.
Whoever is using lab systems, not your personal systems, can take help of Mr. Shenaf. Okay, then I have already shared the Splunk 9.4.2 version. I don't know whether you received it or not from Silembresan sir. You might have received some mail, right, along with your. Huh. This is 9 point, not this one. Mail. Can you please check mail? This one. 3.2. Forward. This one. Just forwarder only. Do you have access to that file? SCADS file? So, who's the one with us? SCADS. No, I shared another thing to sir, not this one. They don't have a WhatsApp, right? Okay. WhatsApp is there, but they can't access from there, right? Okay. I'll do one thing. WhatsApp me. This mail ID, SCADS mail ID. I'll forward that mail. Share that mail. Forward the mail ID to you, right? Send me SCADS mail ID. I'll send this files to you. You share out with all participants. Just wait for 2 minutes. We will receive a mail of all the files that are required. Yeah, yeah. Everyone, please check your mails. So, online participants, please check your mail from SCADS. Some files are shared, some required files are shared. In that, you will have Splunk 9.4.2 and Splunk Forwarder 9.4.2, along with some sample logs. Everyone, please everyone, please download that Splunk. Whatever. Not forwarder. First, you have to install Splunk. Don't install Splunk Forwarder now itself. Install Splunk. If you want Splunk Forwarder, basic you need Splunk server. Uh, Forwarder, you just download this one. Did you install Splunk for Splunk? I'll tell you about Splunk Forwarder later. Okay. You can download measures. Download it. Yeah. Once you are ready, let me know. Okay. It is. Okay. If it is not objecting, let it be. Okay. So online participants, are you following? installed. Yeah. So if you open your home page of your Splunk, it will be shown like that, like on the screen. Okay, those who are installing, let it be. I'll tell you again separately for you also, I'll tell you. Okay, no issues. So now let it install. I'll explain the things of this Splunk tool. Yeah. So what you are seeing here is the home page of your Splunk tool. Okay. What components do you have here on your Splunk tool is search and reporting. Search and reporting means once you have deployed your logs onto your tool, I told you already, right? For police investigation purpose, they will search and do the report based on that analysis. Okay. That is what search and reporting. And another one is auditing. Okay. You can also audit the logs. Once you deploy the logs, you can do audit trials. And Splunk Secure Gateway is nothing but to let you connect your mobiles to this tool that you have deployed in your mission. Okay. And yeah, these are different apps are there connected to your Splunk tool to work for various situations. Let us suppose if you want to analyze cloud logs. Okay. So to deploy cloud logs, some applications are needed. Okay. And if you want to connect to your operating system directly, continuously retrieve the logs, then you need some apps. So all these apps will be available in your Splunk tool. Then, so you can see all these things here. You can add the data and you can search your data. You can visualize your data. You can manage how you can receive the alerts, and you can add some more team members to work on the same log files that are stored in the server, and you can manage permissions to those team members, and you can also configure your mobile devices through this Splunk Secure Gateway, which mobile should be connected to this tool to get the alerts. Okay, remaining all the things are not required. So this is dashboard. Splunk dashboard will let you like have the visualization of your logs, search history, recent viewed, all these things are, yeah. Now, so one thing is, one scenario is you have log files. You have log files in hand. Let us assume your something has happened to your database. I stored something in my server. Usually server means we maintain some databases, right? Like your MySQL, PostgreSQL or something. Okay. So that is what the logs I have given you, DB error logs, database error logs. Okay. So in that is my log file that is already shared with you. That log file is there for investigation now. Now, how to upload that log file or how to dump that log file to your tool for analysis. Okay. This is not continuously monitoring. I'm not continuously monitoring. I'm just dumping whatever the logs that I am having and I'm analyzing. Okay. For that purpose, either you can go in two ways. One is you can see the things here, add data. Okay. Through this add data, you can directly load that log file. Okay. Or so you can also go with data inputs. Different data inputs are there. So in your settings, data inputs are there. So different data inputs are available. From that data inputs, you can go with files and directories. From this also, you can load your file, log file. Okay. So I'm just using the one which is having in my home page. Just click on that add data. So once you go to add data, so in which way you are adding the data, it will ask for multiple options, whether you are continuously monitoring or whether you are uploading a file which you are having. Okay. In my case, I am uploading from my computer. I have a file in my computer. So I am uploading that. Let us see other options also. What is this? HTTP, TCP, UDP. So what are all these things? Protocols, right? Protocols which let you to transmit your data, right? So when you are like transmitting your data, that also will be logged. Let us suppose if you are accessing some web page, how that web page is being accessed by whom, from which IP, from which system, everything will be logged. Okay, connecting to that particular HTTP port where all these logs are being listening. Directly you can connect, you can fetch all the logs from there for continuous monitoring. If you want to monitor how your web pages or website is being accessing, any malicious attack is there. If you want to identify, you can connect to that HTTP ports. And as well as in network, if something is happened, if you want to know, you can connect to some TCP, UDP ports, some to that particular port number, which is listening all these logs. For that, you have to do so many configurations using Splunk tool. So you should know about particular port number, which is listening to your web pages or some other things. Okay. And your firewall should support, or else you have to write the rules, firewall rules, to let that port accessible to your either Splunk tool or some other tool. So these are all configurations that you need to do. For now, what we are doing is we are just uploading a log data file. Okay, I am uploading a log data file which I am having already. So upload. So once you start upload, it will ask you for file, right? Are you ready with your log file? Did you download your log file? If not, download the log file and keep it ready on your system. Download the log file and keep it ready on your system. Who are still installing Splunk? Anyone? Still installing? Installation is done. Okay, Raji, still installation is done for most of you, right? You are able to open your home page, right? So you are seeing this page to add file. Okay, now, so just select your file. If you download your file, just select the file. So I have my sample file here. This is the file shared with you as well. This is my database error file actually. You might have downloaded this error file, right? Just select that error file. Irrespective of the extension, you can dump any file. ERR files, .log files, .txt files, everything is supported. Select your file, open. Once you selected, it will ask you for, on the top, you can see the steps. Okay, on the top, you can see the steps here. Go next. Once you select your file, go to next. It should show you what are the logs on the right side window. If it is not showing, then you have to configure it. Uploaded your file? Do you upload your log file? Yes, please respond. Everyone there. Are you able to see the logs on the right side window? Is it visible? If not, some log files will not be visible like this. There you have to do the configuration. I'll tell you. So source type. Here you have source type on the left side, right? Source type, it is selected as default. Okay, but you can choose what is the source type that you have to take. See, so many source types are there already available in your Splunk tool. Like your application, whether the logs belongs to application or custom logs or database logs or email logs or metrics or malicious network security, OS logs, uncategorized, structured, all these things, some categories are there, right? So my category is database. What is the logs I'm uploading now into the tool? Database. And in that database also, these are not login logs or bin logs. These are error logs. I can choose the source type as database MySQL ID error logs. Okay. And event breaks. So how your event is means usually in your log files, each line represents one log. But in some logs, it is not the case. Okay. In some logs, it is not the case. That's why it is coming correctly here. But in some log formats, it is not the situation. Or there, you can use regress. Yeah. Shena. Shena. I think network fluctuation. Can I use cable? I think morning I should join us. Right. Yeah, it's okay, fine now, right? Okay, here you have some options. Event breaking policy. In event breaking policy, you have auto, every line, regress. So either you can mention how your logs are represented, whether it is every line break or any regress, like any tablet space is only there, or slash line is there, slash n is there. What is slash t, slash r? You know all these things, meanings, right? So how your logs are breaking. Okay, what is first log and second log? How I can get to know this is my log 1, log 2, log 3, like that. That breaks you have to give if your logs are not proper. If your logs are not line wise. Okay, or simply you can mention every line, or auto also you can take if it is giving you correct format. But for me, it is giving correct format now. This is my timestamp and this is my event. Okay. But if you need some more details like this, it won't work here. This is the event ID. All these things are not coming here, but still you can do searching. Okay. So now just go next. Now you have to create an index. You have to create an index. So what is this index? Index means, index is a holder. You are giving some name to that holder to keep all your similar logs. Let us suppose all these database logs I'm dumping. I'll keep in this index. I'll give some index name. I'll create some index over here, which is just create a new index. Is there, right? Source type, what source type that you are using? I told you, right? And let me go back. Source type is nothing but from where you are getting the logs. Logs are of different types coming from different sources. It can be web access logs, right? Or it can be database logs, or it can be your Windows operating system logs or operating system logs, or it can be security logs. So what is that source type? Based on that, your source format will change, right? If you mention what is that source type exactly, then it will understand how to analyze that logs or how to segment that logs. Okay, that is source type. So source type I have selected here. My whatever the logs that I have shared with you are database logs, MySQL tool logs. So I have selected database. In that database also I have so many, like whether it is slow query connections or like correction logs or bin logs or error logs. I have shared you error file. If you observe the extension, it is .err, which is nothing but the error files. If some bad is happened to my database, then those logs will be recorded in your ERR files usually. Okay, that is what I have shared. So I'm selecting my source as MySQL ID error. Source type is that one. Okay, if everything is coming proper here on the right side window, you have no need to worry about that. Okay. Then index. So index, I'm just giving it as just database logs. This index name is of your choice. You can give whatever the index name that you want to. This is not activated. So index name, you can give the name of your choice. From here to here, there is disturbance, lagging is there. So database, I am giving the name of that index as database logs. Database logs. You can give your own name. So that is just you are giving the name to that entire logs. To the same index, again, you can dump some more logs also. Okay. That is just a placeholder. to keep all your logs. Okay. So just save that index name. And choose that index name here. So whatever you have created, that index name, you choose it over here. Okay. Then just do a review. Just click on review. Yeah. Yeah, once you click on the review, just give you all the details. What is your source type? What is your index? All these things. If everything is correct, you can submit your logs. Just submit. Everyone able to see this window? Now you have submitted your logs to the tool. Your logs are ready. If you want to check whether the index is created or not, whether the logs are loaded or not, go to settings, indexes. So there you will have all the list of indexes that you are already having in your Splunk tool. So whatever created by you is database logs. Is that available in your indexes? And just see how many events are there. So for me, it is showing 1.68K events are there in my database logs. Only 2 events. For you? For everyone, it is 2 events. So how your logs appeared in your right window? It is line by line. Are you sure? No, it is not. Okay, then. So for me, it is showing 1.68K events are there. Your events are not loaded log wise. Your events are loaded date wise. If you observe, all 5th some date, all the logs as one event, and the remaining all the logs on another date as one event. That is what happened with you, I guess. Okay, that's why you can see only 2 events. Okay. Okay, no issues, no issues. Now we want to search through the logs. So we want to search and we want to report. Okay. Now let me open my logs again. Now, in all these entire logs, what I am having is I have some malicious logs. So how I created malicious logs is I set firewall to my MySQL tool. How many of you know that MySQL? How many of you know MySQL tool? How many of you worked with MySQL tool? No. Okay. How many of you know MySQL tool is incorporated with firewall? Right? So what this firewall of your MySQL tool will do is, as per the rules, as per the whitelist you have given to that MySQL tool, it will decide whom to allow, whom not to allow. Whom to allow to execute what kind of queries, what pattern of queries. Usually, how many of you know SQL injection attack? What is an SQL injection attack? Right? So what happens in SQL injection attack is we'll develop websites, right? Particularly if you take credentials, when you are giving credentials, you have to give usernames and passwords. So using SQL injections through some cheat codes, you can bypass these passwords. Even though you don't know the correct password, through SQL injection, you can bypass. Of course, there are so many patterns are there in SQL injections. This is one kind of pattern. So how you can bypass and how your query, how you whatever you are giving in that web page, sorry, due to lack of time, I'm not able to show all these things. You will assume your login page, you will have username and password. Okay. So in password, instead of giving password, if you give some 1 is equal to 1, let's say 1 is equal to 1. This is true case all the time. So this web or HTML request will turn into your SQL request when it reaches to your database server. That SQL request will get executed over there and it will give you as a HTTP response. Okay. That HTTP response will give you access to that web page. Let us suppose if you are opening your bank page, I don't know how many of you observed. Now bank pages passwords are not directly verifying. Direct passwords are not allowing. So first it will turn into some hash value, then only you are loading. If you observe, when you click submit your usernames and passwords of your bank pages, it will turn into a lengthy passwords. Right? That is the hash code. That is not the direct password. So only hash codes are now comparing to identify whether you are legitimate user or not. Why? To avoid these SQL injections, to avoid bypassing these passwords. So how this will happen is, so I'll show you one query over here. See here, this particular query, this particular log, access denied for myself, okay, no match in the LO list because I have selected some details from staff by giving username is equal to something and password is equal to something. Usually this is up to this is the proper SQL query. When you are trying to access some web pages using credentials, this is up to this is the proper query. Okay. If your username is matching with whatever the username stored in the database and password is matching with whatever the password stored in the database against your username, then only it will identify you as a legitimate user and it will let you access that page. Or else, how I can bypass is, I can bypass using OR statement like this, or 1 equal to 1. So, if the password and user matches, it will become as a true case. Okay. But I'm forcefully doing it as a true case by giving 1 equal to 1. If my password is matching, okay, allow me. Or if 1 is equal to 1, also allow me. 1 is equal to 1 is always true. That is how SQL injection attacks happens. Okay. So I have created some logs related to that SQL injection attack on my database. That logs are shared with you. And if you observe, the event ID recorded is 01192. Okay. Now my investigation is whether this kind of SQL injection attack has happened on my database or not. Okay. Now you have a knowledge of this kind of logs. So you know now this ID, event ID is 01192. Okay. Now I have to search whether that particular thing is happened in my all the logs. Okay. So now just click on this logo, Splunk Enterprise. You will go to the home page. There you can see search and reporting, right? Click on that search and reporting. You have already indexes, logs are there. Now you just, this is what we call as SPL. Some such processing language, something is there. Okay. So here some querying language is there. through this, we can search through all the logs. Okay. First of all, which logs I want to filter. There are so many indexes. You can give index is equal to whatever the index that you have created, you just give it. Index is equal to database logs. Right? Just enter. You will get all your log events here. If you are not getting, adjust your timeline here. On the right side of that search, you have timeline. Adjust it to all time. Okay. Now, along with this, see, all the logs are loaded, right? All the logs are loaded for me, right? Now, just give some space and give, what is the event ID? 011192 is my event ID, right? I'm going for further filtering for my particular event ID and let me click. How many events are there? How many such SQL injection attacks are there? 18 SQL injection attacks are there on my data. Searching is there, right? So once you have searched, you can save it as a report. Save as report. On the top, save as report is there. You can save all these things as a report. For police investigation purpose. This is searching and reporting. I think time is not enough. Identified? Yeah. That is what I told you. All your logs are stored as 2 events only. That is the issue. Okay, not as an individual events. That's okay, fine. Okay. For you, it is coming good, right? Okay. Now you can filter source type. Just give a slash space and just give 0111192. Okay, further filtering for SQL injection attacks. 0. Index. What is your index? What is the index name that you have given? Then you have to give it as index, not source type. So you have given your index as, that is not available, right? That index is not available. Just check. Okay, you understood, right? So now let me have a quick explanation about continuous monitoring. So I don't know whether you can follow or not, or let me complete. Okay. So if you want to learn more, you can contact me in person, no issues. Okay. So now, for continuous monitoring, what we can do, not file, not about log file. For continuous monitoring, we have to continuously take the logs from some source, right? Now here my source is Windows operating system, whatever right now I have. Okay. Usually in your Windows operating systems, all your logs will be stored as in event viewer. If you type event viewer, you can see all the logs of your OS. So here Windows logs are there, security application setup system, all types of logs will be recorded here of your Windows OS. Okay. In your security, usually the logs related to your login, logout, file access. So all these types of logs will be stored. Okay. So I'll share with you the file, how you can do the Windows logs analysis. So this I will share with you. There are so many event IDs are available. These are all vulnerable event IDs. Okay, 4624, 4625, whether successfully log into your account or not, whether log out of your account, file access, all these event IDs that you have to focus when some attack is happened. So how these are, these need to be focused. If someone successfully log in, what is there? That successfully log in maybe by the legitimate user or maybe by attacker, right? That is again combined with your type ID. Logon type. Okay. If logon type 2 is legitimate, logon type 3 is through network. So the vulnerable one is logon type 10. If your logon type is 10, then someone remotely accessed your mission and successfully log on. Okay. So we can check for these kind of things when you are analyzing Windows operating system logs. This will be shared with you. Okay, you can go through all these things, and different resources are also given, how the data breaches works, how these log events are related to one and each other. Okay. Now let me go ahead with the continuous monitoring. You can install your Splunk forwarder now. Actually, I already have this Splunk forwarder installed, but there are some steps that you have to follow. When you are installing Splunk forwarder, it will ask you for, I'll just tell you, it will ask you for your deployment server IP address and receiver indexer IP address, right? What is this deployment server and receiver indexer is? We can work with this Splunk in a single instance mode or distributed mode. If it is single instance mode, like how I am working within a single mission itself, your client will be there, your server will be there, your analyzing tool will be there. Okay, if it is a distributed, then you will have a monitoring system in another system, which is a deployment server. Okay, where you have all these apps deployed for analysis. And another one is a receiver indexer. Receiver indexer is nothing but the server where you are dumping all these logs. So where you can dump all these logs? In indexes, right? So that is what receiver indexer. Okay. Now you have to give IP. If you are using single instance, you give IP of your local host, which is either 127.0.0.1, or you can mention local host. You can mention both. Okay. 127.0.0.1, your local host IP. Okay. So when you are installing, that is the one step that you have to take care. Now, of course, this is a big process actually. So now what you have to do is, in your settings, you have forwarder management. Okay, forwarder management. Go to that forwarder management. Once you install your universal forwarder onto your local machine, you should be able to see in your forwarder managers, forwarder. What is forwarder? Which is forwarding the logs to your tool. Okay, that forwarded details you should able to see. Okay, so but initially the server class configurations, all these things won't come, but at least this client name, agent type and version, all these things should come. If it is not coming, then you have to configure your receiver. Okay, so just go to forwarding and receiving. In this forwarding and receiving, so you have to configure your receiver. Configure receiving. Okay, so here you have to here like you will have add receiver, some option will be there. It's not coming from. Okay, then you have to give this port 9997 for receiver. Then if you refresh again, you will be able to see that client in your mission. Okay, now if you want to continuously monitor, what you have to do is, sir, Jobin sir, can I take 10 more minutes? Yeah. Okay, you will have a client here. Then, so once you see in your local disk C program files, you will have two folders, Splunk and Splunk Universal Forwarder. Okay. Now what we have to do to continuously monitor is, we have to create an app in such a way that it has to push all your Windows logs to this tool. Okay. For that, how you can create a app is, in your Splunk folder, etc deployment apps, just create one folder of your choice. Okay, so just create one folder. Then if you go and see in this forward manager configurations, you should be able to see that application name over here. Once you refresh, automatically it will come in your tool. Okay, this is the app that you are using to push all your Windows log files to your tool. In order to push all your Windows logs, what you have to do is, you have to write two files. One is inputs file, another one is outputs file. Inputs.conf. These two files are already shared with you. Okay. So in deployment apps, Splunk folder, etc deployment apps, in whatever the app that you have created, in that local, okay, inputs.configuration, which is, I am just writing to push my security logs of Windows events. And I have one more file, outputs.output, which is again sending all these logs to my local server. Okay. Now your forwarder is ready to push all your Windows logs. If you want to send some other logs, this inputs configuration may be different. That is the only thing. Okay. So it will push all these Windows logs to your tool now. Okay. Now you have to connect this app with this client. For that, you will have a server classes. So you have to create one server class. Okay. Here in this server class, it will ask you to connect to the client. Edit agent assignment. In that edit agent assignment, you have to add this agent. Now my agent is local agent, so I'm giving 127 local IP address. If it is not, if your agent is remote agent, you give that IP address. Okay. Then in configurations also, you have to connect this configuration to that server class by edit server class. Now what you are doing, you are creating one server class. That server class you are connecting to that client, and you are connecting this app to that server class. Now everything is aligned. Everything is aligned. Okay. Now, so what I am writing in your inputs, in inputs I am writing, I am taking the logs from security. I am just forwarding only security logs, and index I am creating from here itself. Index I am giving. To which index all these logs should be pushed? So I am taking one Windows logs. This index you have to create over there. This index you have to create here. So I already have all these Windows logs index created. So first it should be created. Okay. Then source type Windows logs. So this source type also should be created. So create your source type from the settings, source types. Create new source type. So Windows logs, it is in some lost page. Windows logs. Okay, according to your inputs format, inputs configuration, you have to create these names, you can change. Okay, source type and Windows logs, just create over there. Okay. And one more thing that you have to do is either you do Windows firewall settings are there, right? Windows firewall settings will stop you connecting to this particular port 9997. Either you have to add this port to your Windows firewall rules or disable firewall for some time in order to get the logs. Okay. So I disabled my firewall. That's why I get all these logs. If I check my indexes, Windows logs, how many logs are there? 260K, 260,000 logs are there from the starting. Okay. You can do all these search operations, all these things. It is continuously monitoring, right? So you can do all these search operations, search, reporting. So all these things, index I'm giving. Windows logs, all these logs are stored here. And if I see successfully login things. So here, if you see, all my logs are, Windows logs are very unstructured. Here, all my logs became structured. Okay. So event code, I'm searching for 4624 is successful logon. Some 71 events are there out of all my 260K logs. Okay. And you can also check this logon type. Okay. Logon type 10. Logon type 10 are suspicious. Or how you can create alerts is, see on the top, I couldn't access stop. Save as alert is there, right? So in this alert, you can mention, you can give some title to that alert and you can schedule it when that alert should happen. Okay. And in order to schedule that one, you can also schedule event wise. So you can say these number of results means this remote access logons, successful logons exceed 3. Number of results is once or is greater than 3, is like that. You can set and it trigger action. Once that logon incident is happened, what should be done? Whether it can be recorded as a log event again, or it can send email to you, or it can send a alert or notification to your mobile. Here send to Splunk mobile is there, right? Once you configure your mobile to this Splunk tool, it will send you notification about this particular alert. Someone remotely log in to your mission. Okay, that message also you can create. Description will be sent as a notification to your Splunk mobile. Right? Yeah. You can save that. So once this is done, once you configure to your mobile, you are ready to monitor your missions or safeguard your missions. Okay. Of course, I went a bit fast in the second part, but I'll be available here only. Of course, this is your last day, but you can have my mail ID. You can ping me anytime. If you are interested towards this log analysis, you can contact me anytime. We can have a meet. We can have a chat. Okay. Please feel free to contact me anytime. Thank you very much. Online participants, I don't know how far you grasp the things. Anyways, thank you for keeping silent.
Any doubts you can ask now?
Okay, so I didn't
Wonderful.
leave any time to do. Yeah.
Or doubt, ma'am.
Yes. If it is big one, you can come to my cabin. Okay.
Okay, ma'am. My system, I have set up a Splunk in my system, ma'am.
Mhm.
I have given a alert notification to my mobile, that setting I have configured. But what if my system doesn't have internet connection? Will it give notification or not?
Actually, Splunk don't work on internet base.
Okay, ma'am.
This is not internet base. Internet connectivity is not required. Once you establish, somehow you will get the notification. Okay. This is just through Splunk secure gateway, not through internet. Okay. You will get notifications.
Yes, ma'am. That's what.
Ma'am, over to the online participants also.
Yeah.
Just ask any doubts, please unmute and ask.
Please, I can't check the chat box.
Chat.
Can you please ask?
There are 7 chats now.
Yeah, no doubts, it seems. So in my consideration, if you have any doubts, if you have no doubts, the two possibilities, either you have understand everything or you didn't understand anything. So I don't know about our online participants. So the same option for you, if you want to connect with me, you can ping me anytime to my email ID.
Thank you, ma'am. Thank you, ma'am, for the insightful session on incident response using log analysis through Splunk. Your clear explanations and practical demonstrations have greatly enhanced our understanding of incident response. We truly appreciate your time, effort, and valuable contribution to the success of the FTP. Thank you, ma'am. Okay, to the participants, we are going to have a 10 minutes tea break and we'll resume the session immediately. Okay. Welcome back, everyone. Next, we are moving to our session, Privacy Preserving Using Federated Learning by Dr. Akash K. Nair. Let me give a brief introduction about him. Dr. Akash K. Nair is currently working as an assistant professor in the Department of Computer Science and Engineering at IIIT Kottayam. He completed his PhD from the same institute, where his research focused on privacy-aware and energy-efficient federated learning frameworks for mobile IoT systems. He has previously served as a visiting researcher in the Weisnet Group at the University of Agder, Norway, as part of the Indo-Norwegian collaborative project on autonomous cyber-physical systems. He was also a doctoral fellow at IIT Mandi under the iHub HCL Foundation, working on the intersection of federated learning and human-computer interaction. Additionally, he contributed as an academic assistant with DADB Germany on 5G training and lab development. His expertise includes federated learning, privacy preservation, edge intelligence, and AI for security, with applications in CPS, mobile IoT systems, and critical infrastructure. His work has been published in leading venues such as IEEE Transactions, Elsevier journals, and core conferences including ACM and IEEE. He is also a co-inventor on 2 Indian patents on secure CPS, an active reviewer for top-tier journals like IEEE and Elsevier. Dr. Akash focuses on merging academic research with real-world use cases. So we warmly welcome you, sir, to the session.
Yeah. So thank you for the intro. It was pretty long. Okay. So my topic for today will be the general idea is federated learning for privacy preservation. We'll be investigating how exactly it works, to be very frank. You will be aware of what exactly federated learning is, right? Professor, we know that already taken one session. So the idea, like the basic or the fundamental idea of FL itself is like, how do you preserve the privacy of a machine learning model without the need for actually data transfer? That is the motivation behind formulation of FL. Fine. So like if you are discussing with respect to actual ML algorithms, right? In the traditional scenario, we call it a centralized ML algorithms. Fine. So what happens in centralized ML algorithm is, assume that you are having your own data. Fine. You are having your personal data inside your systems, and then you want to develop an ML model out of it. Okay. So you need to aggregate this data at some particular point. Fine. Assuming that there are like n number of participants, or like 3 or 4 participants, and each person is having, let's assume, maybe 1 GB of data. Fine. I'm having 1 GB of data. Similarly, other 3 participants are there who are also having just 1 GB of data, right? I hope you guys will be familiar with ML algorithms, right? Simple MLs at least, or like DL algorithms. So technically, 1 GB of data is not relevant to actually construct a model. Okay. But we also have a requirement of an ML model in that particular scenario. So what FL proposes is, you don't need to transfer your data. You keep your data with yourself. I'll give you the model. Fine. I, in the sense, a centralized orchestrator or a server, whoever it is, they'll give you the model. You are just expected to train the data at your end. After training, you will be getting some kind of byproduct. Okay. As of now, we'll call it byproduct. We'll formulate the actual term once we proceed. Okay. Some byproducts will be there. The byproducts will be again sent back to the server or the orchestrator as such. Fine. Now the orchestrator has technically like 4 separate byproducts from 4 different entities, right? Now he needs to think what is to be done with that. So the simple thing that comes to our mind is, let's just average it. Fine. I'll just average it, or like let's configure the mean out of it. Fine. So once that is done, I'll be getting with a global byproduct. Fine. That is what FL simply does. Now we need to define what exactly is byproduct, or what do you mean by averaging as such. Fine. Those are the 2 important pillars of FL. Okay. So assuming that you are training a model. Okay. You are training a DL model. Fine. What happens inside the model exactly? You're basically giving the data. You're training the model, right? Even though we call it training, the thing that is happening inside the model is weight updation, right? If you are familiar with transfer learning, correct? If you are familiar with transfer learning, what does it do? Transfer learning already has a model. It takes the weight out of the model and then puts it in another scenario, right? Then we just need to fine tune the model, correct? That is what transfer learning does. So ultimately, the knowledge of a particular ML or DL model, sorry, not ML, the knowledge of a particular DL model is its weights. Fine. So in federated learning also, the byproduct, as we told, right? It is the weights as such. Fine. So when a model is training, its weight is getting updated, irrespective of the fact wherever the training is occurring. Okay. The only difference in FL is the weight updation happens at this end. Fine. Okay. In this figure, if you are seeing, right, you're having like a circular kind of thing. So in the outer edge, you are having like multiple devices. It's noted as model 1, model 2, model n, correct? And in the center, you have a basic thing which is referred to as aggregator, correct? What architecture is this? This is a basic client server architecture. Fine. I have a server at the center, and then I have my clients. Okay. And here you can see like bidirectional arrows. The bidirectional arrows tells me that data transfer happens in both directions. Fine. This is the simple architecture of FL. We'll explain what are the different steps in FL. Fine. So to start with, a typical FL round works like this. The first step is global model initialization at the server. Fine. So depending upon the task you are expected to perform, let it be NLP, let it be computer vision, let it be anything. Okay. ML, even ML. Fine. For the time sake, we'll just assume it to be ML also. So depending on the particular task, you will be allocating a model. Fine. Who allocates the model? That's the first question. The model is allocated by the server. Fine. The server, you call it the server, you call it the orchestrator, you call it some kind of centralized entity, whatever name it be, it basically finds a model. Okay. And that model will have a fitting nature towards the data. Okay. So once the model is identified, step number 2 begins. That is selecting the clients. Okay. Assuming your network has a large set of clients, let's say maybe like 50,000 clients, 1 lakh clients, it's not necessary that you will be employing every single client in that. Fine. You can go for a client selection ratio, 10%, 20%, whatever you feel is necessary. Fine. Okay. So you'll select the clients. Once the selection has been done, I'll be sending my model to the clients. Fine. Now the model has already reached the clients. That is step number 3. Fine. So once the model reaches the clients will do their training as usual. Fine. As of now, the client is not bothered about what is happening. He just got an ML model. He has the data. He's training on the data. Fine. Once the training has occurred, technically, I'll be getting an updated set of weights, right? Because let it be any kind of model training, the model weights before training and after training will not be identical. That is what learning actually is referred to, right? So basically, we call learning as gaining knowledge with experience, right? So in this context also, the local model or the client is training a model, and then he is gaining experience with respect to his personalized data. Fine. So once that experience has been gained, the weights will be updated. Correct. So again, now the client side procedure is over, or as we told before, the byproduct is already generated. Fine. Now the client just packs this byproduct or packs this weight into something called as gradients, parameters, whatever you want to call it. Okay. They just pack these weights and they just send it to the server. Fine. Once these weights reach the server, we move to the last step, the 5th step, that is aggregation. Fine. Aggregation is what I refer to as averaging. Okay. Aggregation is what I refer to as averaging. So generally, he'll collect everything. Assume this to be balls, or like assume this to be a piece of dough as such. We have the maida dough, right? Or chapati dough. Assume like clients are sending one bit of dough. The server is collecting all the doughs and is just like mashing it up. Then again, it becomes a big ball of dough. Correct? That is what happens at the aggregation point. Fine. So after the aggregation, this process keeps on repeating. When do we say a machine learning model stops training? Generally, not in this context. Generally, when does a machine learning model stop training or a deep learning model stops training? 2 possibilities are there, right? One is you get the required accuracy. Correct? You are setting the accuracy to be 90%. You are getting the required accuracy, right? What is that kind of stopping called? It's called as early stopping, right? We don't want the model to overfit. So we tell the model that, okay, once you have reached 90%, you stop on yourself. Fine. That is called as early stopping. Second one is based on the number of epochs or iterations. You're training for 10,000 iterations. Once it is done, you just stop training. Fine. The same approach follows here as well. Okay. The same approach follows here. Thus, like the global model, right? Once the global model has gained a considerable amount of accuracy, let's say maybe 90%, 80%, whatever it is, it stops training. Second one is once the epoch has reached, it stops training, right? Okay. Now the next question should be, what exactly is epoch in federated learning, right? Because we told that the mixing up of dough happens, correct? That is the aggregation happens. Then client side training also happens. So technically, we are having 2 levels of training, right? One at the client, one at the server. Okay. So the classical term, right? Epoch refers to the client side. Okay. Or local iteration. We call it local iteration. You can call it epoch, whatever you want. Okay. And in the server side, we call it global rounds or communication rounds. Fine. So when you read any kind of FL codes, right, you will be coming across these two terms. So whenever it is written like global round is equal to 3 and local epoch is equal to 2000, it means for every single global round, the client is training for 2000 epochs. Okay. Got it? In the sense, the dough is being given to the client is mashing it up for 2000 rounds. Fine. After that, he's sending this piece of dough to the server. The server again mashes it up, makes it a big bowl, then again sends it back. Again 2000 wrapping is happening, again sending back. Like that 3 times will be happening. That is how like we generally define FL scenarios. Fine. Okay. So where does FL gets employed in real life scenarios? Right? That is a big question, because as per my or what I make of it, every single technology will be only applied if it has a strong financial background, right? You're familiar with blockchain? Blockchain, at least you have heard of it, right? Yeah. The main backend of that thing itself is like Bitcoins and those kind of stuff, right? Yes, it has other applications, but major thing is that. Similarly, FL has monetary applications in these scenarios. Fine. First one is healthcare industry. Assume that I'm having some kind of like health issues. Fine. I'm not comfortable sharing my data. What do? I go for FL. Okay. The second thing is smartphones. Yeah. The most prominent or the most widespread use case, every single person will be familiar is Google keyboard. Fine. Yeah. You guys are from like Kerala itself, right? Yeah. Whatever it is, Tamil also. Okay. We use the term English, right? That is we type Malayalam in English. Similarly, we type Tamil in English, right? I will be writing one word in a peculiar way. You will be writing it in a different way, right? How does my system basically like give me that exact prediction? If it is a global prediction, right? It should be giving the same exact prediction to every single person, right? That doesn't work like that. You will be getting your personalized prediction. She may be getting her personalized prediction, right? So that is facilitated by FL. The data never leaves your phone. Model comes to your phone. It trains it, and then this happens. Fine. So personalization in like these kinds of keyboard is one major factor of FL. Fine. Then we have like smart cities, finances, and those kind of stuff. Okay. Those are the general applications of FL. So moving on to the actual question, does federated learning automatically guarantee privacy? The simple answer is no, it doesn't. Just because the data doesn't leave your system doesn't mean your data is already safe or always safe. Fine. If an attacker is skilled enough, he can access your data, whatever be the situation. Fine. Okay. When we log into certain systems, right? We use the HTTP login format, right? Do you think that is safe? No. With simple ARP spoofing, right? With simple ARP spoofing, you can gain access to that, right? Similarly, even though the data is local, there is no guarantee of privacy. Fine. That is why we have kept a statement. What you can share still reveals what you don't. In the sense, even though you are not sharing your data, you are sharing the gradients or the parameters or whatever it is, right? That parameters are capable enough to leak whatever data you have already like saved. Fine. To put it in a very simple manner, right? Assume that you are having a number. We are playing a game. Okay, guessing game. You are assuming the number to be 4. Fine. You are giving me a hint. You are telling me that the number lies between 5 and 6. Sorry, like 3 and 5. Is he giving me the number? No. He's not giving me the number. But he has already given me enough information that the number is 4, right? That is what happens here also. The client is not sharing his data at all, but he is giving information to others stating how I can reach the data or how does the data represent itself, right? That is what happens. So technically, data locality never ensures privacy in FL. Fine. And what are the common possibilities through which the privacy can be breached? Fine. So some of the common attacks which are stated here is gradient leakage, membership inference, and model inversion. Fine. You will be familiar with gradient leakage, right? Vinod sir had that session in the first this thing. He called it DLG, data leakage gradient, like that. Okay. So basically what happens is you are just leaking your data. It can be intentional, it can be unintentional. Fine. Assuming that you are carrying a bowl full of water and you are expected to take this water to the other end. Would you leak it purposefully? You won't, because your task is to take it there, right? But unintentionally, water may go out of the pot as such. That is what happens in this one also. The intention may not be malicious, but ultimately data can be lost. Fine. That is what general leakage refers to. Yeah. So what is the solution for this, or how do we preserve the privacy in such systems? Fine. So the initial or the go-to answer is DP or differential privacy. Fine. You had a session on DP, sir? No, they didn't have a session on DP, right? Okay. So the first thing is DP. Second one is called a secure aggregation. Okay. Third one is SMC, and the last one is adaptive privacy. Okay. You might be already familiar with the term homomorphic encryption, right? What does it do? It basically encrypts the data and processes on the encrypted data, right? Yes, if you search the materials, you will find HE in FL, but we have not introduced it here because HE technically doesn't work for FL. The simple reason is, assume that you are expected to do some basic arithmetic operation, maybe summing A plus B equal to C. Fine. You're doing it in normal text, you can do it like this, correct? When you encrypt it, the dynamics just increases exponentially. Okay. So technically, HE never works for these kind of things. Same for SMC also. SMC is secure multi-party computation. You have the concept of smart contracts and all in blockchain, right? You are basically managing a ledger, correct? That same ledger is managed in SMC also. Just it's kind of a predecessor version of the blockchain. Okay. If you don't want to invest in blockchain, if you don't want to overkill it, you go for SMC. Okay. That is what SMC does. DP in the other case is a widely employed thing. Basically, you are just putting some kind of perturbations into the data. Fine. We call it perturbations as kind of a jargon. The simple thing is like noise. You add some kind of noise into the data. Fine. And the last one is adaptive privacy. Adaptive privacy is a newly evolving term. We'll just coin it as we go. Fine. So what are the general threat models in FL? Fine. Threat models in the sense attack scenarios or attacks that are possible in FL. Fine. The general classification is mainly based upon two things. Simply to put it, the modus operandi using which the attack implements itself. Modus operandi in the sense, how do the attack work? Fine. So two categorizations: privacy-based attacks, security-based attacks. Fine. Privacy-based attacks are those attacks which simply tend to analyze your data or gain access to your data. Fine. They are more kind of gossip kind of people. Fine. They are not bothered about destroying your system. They just want to know what you are doing. Okay. Even in that, we have two categories: honest but curious, then perfectly malicious. Fine. See, assuming that two people are sitting and talking, one person is just sitting next to him and overhearing the conversation. Okay. That is called as honest but curious. He doesn't have any malicious intent, but he just want to hear what you are talking. Normal gossip, right? Another person is sitting and hearing, and he uses that data to basically work against you. That is called as malicious. Fine. So that two categories comes under the privacy attacks. Fine. The second one is security attacks. In security attacks, the adversary has a simple motive: just destroy the system. Don't leave anything back. Just destroy the system. Fine. That is what happens in like poisoning kind of attacks. Okay. So the general poisoning attacks are model poisoning, backdoor, and Byzantine clients. Fine. Even though those are termed as three separate entities, it's more kind of a gray zone. One complements the other, then the other one again complements the other. It's something like that. Fine. And simply to formulate it, privacy attacks aims to steal data, whereas security attack aim to break or corrupt the model as such. Fine. Just get the model done with. Fine. That is the motive of difference in both. Okay. So these are the classifications. We'll be analyzing each attack in detail. Okay. So starting with security attacks, the first attack is called as model poisoning attack. Fine. Model poisoning attack. As we told, these are security attacks. Their idea is to destroy the system. So how does model poisoning work? Model poisoning basically injects some kind of poisoning into the data. Fine. Into the data or the model. And what is the ultimate aim with that? The model will not be able to function as usual. Okay. So they'll be adding some kind of malicious data, or they'll be adding some kind of noisy data to the model. And that model will be eventually aggregated into the global model. Fine. Once that model gets embedded, or once that poisonous gradients get embedded to the model or the global model, the model starts behaving in a way it shouldn't be. Fine. Some of the common techniques are like 1 pixel attack and those kind of things. Fine. The idea is simple. Just put some kind of trigger or some kind of poison in the data such that the model eventually gets poisoned. It's not kind of a radical poisoning. It's eventual poisoning. Over a time period of multiple epochs, the poison will be embedded into the global model. Okay. And why is it so much potent for FL systems? The reason being, like single or a combination of malicious clients, right? Multiple clients, they can critically sabotage the system completely. Fine. Like assume that 10 clients are there. 3 clients is mimicking the system to understand that 5 should be declared as 6. Okay. 5 should be declared as 6. So eventually the system will be understanding it in that manner. Okay. So then whenever the person enters 5, the system will be labeling it as 6. That is what happens in that context. Fine. And what are the major defenses for that? The initial defense for these kind of attacks is robust aggregation. Fine. Robust aggregation in the sense that is a mechanism which ensures that these kinds of gradients or these kind of malicious entities don't enter my system. Fine. You'll be seeing this word frequently now onwards. Crumb, trimmed mean and median. Fine. Trimmed mean is simple. Basically, you are calculating the mean, trimming it. Trimming it in a way such that the outliers are being removed. Fine. The median also acts in the same way. Okay. Crumb is the new word. Crumb is a mechanism where you ensure that clients are being selected based upon their divergence with other gradients. Fine. You are familiar with the term divergence, right? No. In normal sense, there is a particular vector. Assume there is a particular vector. If 2 vectors are aligned, they will be traveling like this. Correct? If 2 vectors are not aligned, they will be traveling in this orthogonal direction. Correct? So how do we calculate the divergence? You either use like standard approaches or like out of the shelf approaches like KL divergence or maybe cosine similarity, those kind of things. Okay. Basically, model weights are vectors and you analyze the divergence of vectors. How much one is related to the other. Okay. That is what Crumb does. Fine. So after Crumb, you have something called as client reputation models or client reputation modes. In the sense, how much is my reputation? How does it affect the model? If I'm highly reputed, trust him, blindly trust him. Okay. If he's not reputed, just be cautious when you accept his data or like request, whatever it is. Fine. Last one is the standard anomaly detector. Whenever something is not right, just try to be cautious with that. Fine. After model poisoning, we have something called as backdoor attacks. Fine. So ultimately, backdoor attack is kind of a byproduct of model poisoning. What do you mean by backdoor in general? You are having a front door. Everybody enters to the front door. You want to push someone out, right? Without anybody noticing. How do we do it? We do it through the back door, correct? That is the way this one also works. The thing is, as I told, pixel replacement attacks, right? There is a particular category of attacks called as pixel replacement attacks. Fine. If you have already worked in ML, we call ML data in the format of pixels, right? 28 by 28, 226 by 226. Assume that you are just replacing one single pixel. In the 226 by 226, you are just replacing a single pixel. If you are able to properly place that pixel, that data will convey entirely something else. That is what single pixel attack does. It uses something called as differential evolution. It's a nature inspired algorithm. Fine. Basically work on something until you configure it out. That is what differential evolution does. Single pixel attacks basically helps you to embed a backdoor. What does the backdoor do? Backdoor basically gives access to a third party into the model. Okay. Assume you two are generating the model. You are having a poison data or you are having some kind of poisoning in that. Ultimately, the model has a backdoor. So I am the adversary. I'll be making your model do what I want. Okay. This may seem like really what naive in genuine like real world context or just in theoretical context. Assume this model to be a disease classification model. Okay. Assume this model to be a disease classification model. Whenever you are giving a data, in the place of it to be what normal, the model is showing me that he has cancer. Fine. Or in the reverse manner. Or assume it to be a face detection model. Whenever somebody is showing any kind of face, it is saying that it is me. Fine. That doesn't work, right? That is where these kind of like attacks has real world relevance. Fine. So backdoor is basically a byproduct of model poisoning or data poisoning.
ultimately the idea is that the model will be embedding a backdoor in the system such that the adversary can do whatever he wants, okay, or he can bypass whatever is happening in the actual model. And the general defensive strategies are update inspection, robust aggregation, and trigger detection model. Update inspection in the sense, whenever such inspection or whenever such gradients are coming, the server is expected to analyze the gradients, make sure that such deviating gradients are not present inside the system. Fine. That is what comes in update inspection. Robust aggregation, we already told, crumb, trimmed mean, those kind of mechanisms. Fine. Any kind of aggregation which has a particular level of resiliency against noise. Okay. The last one is a trigger detection mechanism. Basically, when does it get triggered? So as I told, right, the single pixel or the replaced pixel is the trigger for backdoor attacks. So whenever the system is finding that replaced pixel, he understands that, okay, this pixel is telling me I'm supposed to do some other task. That kind of trigger you are expected to identify. That comes in this part. Fine. The next attack is Byzantine attack. Basically, you also call it as Byzantine clients as such. Fine. So the clients who are having poisonous data, right? The clients who are having malicious intent or adversarial clients, you call them as Byzantine clients. Byzantine attacks are more kind of an umbrella term, in the sense it just refers to poisonous clients. The clients can employ any given kind of attack approach. It can be poisoning. It can be simply adding noise. Okay. The general idea of this thing is either you crash the model or you make the model work the way I want, not the actual task. Fine. So generally we have two kind of tasks in ML based, like these kind of things. Fine. One is the main task. Second one is called as the adversarial task. Fine. Main task is the task given by the client itself. The adversarial task is the task given by the adversary. Fine. So what Byzantine client does is either he pushes the model to do the adversarial task. Second thing, he pushes the model to fail on itself. Fine. Those are the two things Byzantine clients will do. Okay. So the problem is in these kinds of networks, right? Like whenever a small portion of clients decide to work together, it becomes really annoying for the model. In the sense we call it collusion attacks. Fine. One or more people decide to overpower the majority. Fine. That becomes collusion, and collusion is generally pretty much potent in FL systems. Okay. That is one major feature of Byzantine attacks. And then like the defensive measures are Byzantine resilient aggregation, reputation scoring, and anomaly detection. Fine. Reputation scoring we already told. If a client has higher reputation, don't worry about him. He won't be malicious. Okay. And how does the reputation be is assigned? Based on historic data. Okay. If I'm having assume that I'm a 7th semester student, right? I'm having good marks in first 6 semester means I have a high chance of getting good marks in 7th semester also. It's not guaranteed, but the probability is high, right? That is what reputation stands for. Fine. And the first one is resilient aggregation, same crumb, trimmed mean, median, those kind of mechanisms. Okay. And the next one is membership inference attacks. Fine. So now we'll be starting to go into privacy attacks as such. Till now, we referred to the set of attacks which are called as security attacks, right? So now the modus operandi will be changing, or the aim will be changing. Now their aim will not be to destroy the system. Their aim will be to just gossip or just get something out of the system. Fine. So to start with, it's called as membership inference attack. What is called by membership in real sense? To check whether somebody is associated or affiliated with something, right? That is what membership means, correct? So this one also does that. The only difference is membership is with respect to data set as such. Fine. Membership is with respect to data set. I already told you that data set is hidden, right? The adversary doesn't have any knowledge of data set. Then how do you infer whether a particular data belongs to the training set or not? How do you do that? The simple logic is you just give him the data, right? You just give your data to the model. Let your model generate the prediction. Okay. In ML, we have something called as prediction score, right? In ML, we have something called as prediction score. Like we have the ROC curve, AUC curve, those kind of things. So basically, I hope you are familiar with ML, right? That is why I'm just using those terms directly. Or to put it in a very simple manner, you have trained your model using some data. Fine. Assume it to be your face. Okay. You are creating a face detection model. and the model is trained on your face only. Fine. If the model is being given my face, what is the possibility? The model will say that I don't know this face, right? It will say that no, correct? And with how much confidence the model will say? Typically above 50, right? Above 50, the model will say that I'm 60% sure that this is not the guy, or even 90% sure that this is not the guy, right? That 90% or 60% is called as confidence score. Fine. Similarly, if you give your face itself, the model will say that I'm 90% sure or 100% sure that this is this person, right? So that is the concept of confidence score. Okay. So similarly, in membership inference, the system or the adversary simply gives the data to the model. And if the model basically gives you prediction with high confidence, the model has already been trained on that data, right? If the model is giving you prediction with less confidence, the model has never seen that data, right? Simple logic, correct? I'll just ask you a simple question. What is the simplest way to get a Gmail account blocked? Somebody else's. You are having some kind of difference with some person and you want to get his Gmail account blocked. What do you do? Easy thing, without having any access, nothing. What do? You basically keep on giving wrong passwords. You give it 4 times, you give it 5 times, you give it 10 times, his account automatically will be blocked, right? If you already know the Gmail ID, correct? That is the same logic these people also use. They just keep on giving data. Once the model generates a high prediction output or with high confidence, that data basically belongs to the model. Okay. Yeah. So coming to the defensive strategies, the first one is DP, again, differential privacy. We won't be explaining any of these now because we have dedicated slides for that. Okay. So just assume that DP is one defensive strategy. Second one is regularization. What do you mean by regularization? It has nothing to do with security. It is pure ML term. We use regularization or we use dropout kind of thing. So basically when a model is expected to overfit, you just reduce the size of the model. Fine. You just reduce the norm of the model. That is what regularization means. Okay. The next one is early stopping. The thing we told already, if a model is reaching 90%, just stop training. Don't overdo on anything. Fine. The next kind of attack is model inversion attack. Okay. So the objective of model inversion is reconstruct sensitive input features from the model's output or shared gradients. Fine. So assume the model is creating predictions or he is sharing the data, gradients in the form of gradients. So you basically gain access to that gradients and try to reconstruct what is happening. Fine. Reconstruct in the sense you are getting bits and chunks. Fine. Assume this to be the puzzle problem. Okay. You know puzzle, right? We won't be given the puzzle all at a stretch, correct? You'll be given one piece at a time. So if you are patient enough, you can gain all the pieces and basically reconstruct the puzzle, correct? That is what happens here. Okay. That is what model inversion attack does. You are just reverse engineering the setup. You are getting the byproduct. From the byproduct, you are just tracing the steps back and finding the initial input. Fine. Yeah, I'm just running through because already we are reaching the time. Okay. So the general defenses are gradient clipping, secure aggregation, and DP. So gradient clipping, as we told before, you already have a very big distribution of data. Fine. You already have a very big distribution. That distribution will be having outliers. That is mandatory. Every distribution will be having outliers unless they are filtered. Fine. So you are just removing the gradients which comes in the periphery of the distribution. That is what is called as gradient clipping. Okay. Like assume the distribution to be 1.02 to 0.5 or 0.55. Fine. So you are just clipping it in the sense you are taking it from 1 to 0.5. That is what is called as clipping. Okay. The second one is secure aggregation. In secure aggregation, it works almost similar to HC or homomorphic encryption. Fine. You are just encrypting the data or you are securing the data and working on that data. Fine. The next one is leakage attacks. You should be familiar with leakage attacks. He already explained it mathematically. The idea is whenever you are transferring something, you are expected to lose some data. Fine. Even when we transfer electricity to power lines, right, we'll be losing data like through heat, correct? Similarly, data will be lost. So if an adversary is skillful enough, he can make use of the data and basically launch a wide variety of attacks. So the gradient leakage attacks, right? They are not isolated attacks or independent attacks on themselves. they act more kind of a basement for other attacks. Fine. So once you have the leaked gradients, you just need to interpret the gradients and keep it aside. Fine. This leaked gradients can then be used for multiple attacks like model inversion, reconstruction, everything it can be used. Fine. So gradient leakage acts as the fundamental aspect of all privacy attacks. Fine. Again, with gradient leakage also, the simple mechanism or the simple defense is DP. Fine. DP is the simple defense. The second defense being told is gradient compression. Gradient compression in the sense, yeah, to put it in a different way, assume that there is a channel and that channel is having like high traffic. Fine. The channel is having high traffic. How do we reduce the traffic? We just compress the data, right? We just compress the data. The idea is when the data is compressed, there is less volume of data that can travel inside the channel, correct? Same thing is applied here in security perspective. The logic is, if you are having 1 GB of data, there is a high chance that something might be lost out of the 1 GB, right? It is simple sampling, mathematical sampling. When you have higher number of data or higher volume of data, there is a high chance that higher volume of data leakage can happen, right? When you reduce the data, the susceptibility of data leakage also reduces. That is the motivational force behind gradient compression. Fine. You reduce the data, you increase the security. Fine. We, in security terms, we call it a surface of attack or attack surface as such. When data is reduced, there is less attack surface for people to come and attack you. Fine. The next thing is delayed sharing. In the sense, you wait and reduce the data sharing eventually. Fine. The next thing is property inference attack. So this one is also a part of inference attack. The first one we told was membership inference, in the sense whether a data belongs to the actual training data or not. Coming to property inference, this is more kind of a sensitive thing, in the sense, like I being a client, I have my own demographic details, right? What is my age? What is my weight, height, or my, let's say maybe physiological measurements, everything, right? That kind of inferencing, when done on data, is called as property inference. Fine. You won't be directly going for the data. You are not bothered about the data, but rather you are bothered about a property that the data has. Even if it's like general distribution, it can be something even like what is the standard distribution of the data, or what is the like general deviation of the data. Fine. Even that, when the adversary is trying to infer, that is called as property inferencing attacks. Fine. This is a subcategory of the bigger inferencing attacks as such. So inferencing simply means you try to gain access to some kind of data which you are not expected to have. Fine. That is what inferencing does. Inside inferencing, you have property inference, membership inference, data inference, and those kind of attacks. Fine. So again, here also, the primary defensive mechanism is fair model training, dropout and feature masking, adversarial revelations. Fine. All three relates to machine learning rather than this particular context. Okay. So the next question is, we just introduced the major threat models, the common threat models, right? You have other threat models. It's not like these are the only things. You have the classical DOS, DDoS, every kind of thing. Fine. Like spoofing, everything works here also. These are the models which are limited to FL, or the attacks which are limited to FL. Fine. Then the next question is, what does privacy mean in FL, right? Now, like initially we told that the data is hidden, so the system is private. Now we are getting to a point where we are contradicting our statement, saying that even when data is hidden, there is no privacy, right? If the person is skilled enough, you can gain access to whatever you want. Fine. We have got to that point now, right? So now we are questioning ourselves, is data really private in FL? The answer is no. Privacy in FL is not equal to no data sharing. Fine. So basically, in order to gain privacy in FL, or the idea itself of privacy in FL is to limit the susceptibility of attacks. Fine. That is the general idea of privacy. Okay. It doesn't mean you are not expected to share any kind of data. You have to share the gradients to generate the model. Just find a way in which the gradients can be shared safely. Fine. That is what privacy means in FL in the current scenario. If you are referring to papers like 5 or 6 years back, right? They will just give you one statement. Federated data is localized, so data is private. That scenario has already changed. Federated data is localized, but it doesn't mean it is private. It is always susceptible to attacks. Fine. That is the current definition of that. So what are the techniques? DP, SA, FD, and personalized FL. Fine. We'll discuss everything in separately. So to start with, the question is, what is differential privacy? Fine. As the name states, it is a privacy enhancing mechanism. And the simple idea is you add perturbations to the data. Fine. You add perturbations to the data. Perturbation is some kind of jargon. Jargon in the sense the word we use to what? Just make it complicated. To put it in a very simple manner, it's just noise. And what is noise? Noise is just a distribution. Fine. Noise is simply a mathematical distribution. Okay. It can be Gaussian noise. The major types of noise we use, right? Gaussian noise, Laplacian noise, exponential noise, and those kind of stuff. The noise you guys see in machine learning, right? Ripple noise, black and white noise, those are not actually noises. They are noises with respect to 70s, 80s, that kind of era. Okay. Nowadays, this is what noise is called. Okay. You have Gaussian, you have Laplacian, you have exponential, other kinds of noises. Generally, it is just a mathematical distribution. Fine. So what is actually done is you take the data, you take the gradient, whatever it is, you embed noise into the data. So what happens is if the data is having a value 5, you're adding noise to it. So technically the value of 5 will deviate. It can be either 5.5, it can be either 4.5. Okay. It depends how you are adding the noise, but basically the data will be deviating. Fine. So what happens is even when the adversary is gaining access to the data, he'll be understanding that, okay, this is somewhat closer to 5. Okay. But it's not 5. He'll not be able to understand it is 5. He'll be understanding, okay, it is 5 plus or minus 5. That will be the understanding the adversary will be getting. If you're referring it to in like what? NLP terms, right? You are sending a 4-letter word, LOVE. Fine. You are expected to send a 4-letter word, LOVE. Fine. You are adding noise to it. You are what? Masking or adding noise to the second and third letters. Okay. So now O and V is pretty much masked or noise is added. Now the adversary can interpret it to be LOVE. He can interpret it to be LIKE, right? Both are possible. The adversary is not aware what exactly is happening, right? But then the question is, how does the data become useful, right? If assume that the communication is happening between two couples as couples, fine. So basically, depending on the historic data, the receiver will be understanding, okay, he is meaning love rather than like, right? That is how DP works. Fine. The general logic of DP is distort the data such that the adversary is not able to understand it, yet the receiver is able to understand it. Fine. That is the general logic of DP. Okay. So this is a mathematical equation of DP. We have something called as like epsilon DP, right? Epsilon here basically stands for the privacy budget, and then delta stands for the probability of meeting the budget. In simple terms, privacy budget means how much data you can add or how much noise you can add and how much it can distort your signal. Fine. That is what privacy budget means. And basically delta means, okay, are you able to maintain that budget or not? That is what delta means. Fine. So in like federated learning, how DP works is you already calculate the gradients. That is the smaller chunks of dough. You already calculate the gradients. So in the dough, you put some kind of additional things, sweetener, whatever spicy things you want to put in. That spicy or sweetening things is called as the noise. Fine. So the noise will be embedded to the gradients. Then the gradients will be sent to the server along with the noise. Fine. So at the server already has an understanding of how the noise is being used. Fine. So what happens is he'll know the noise, how the noise is. He'll be just keeping aside the noise and he'll be using the gradients only. Fine. Okay. That is what happens in DP. Keep the idea simple. You are just embedding noise into the data. Fine. Nothing specific. Just make sure that the noise doesn't distort your data to such a high extent that data becomes useless. Fine. We have two terms in this: privacy, utility. We'll just show the privacy utility curve. Yeah. So two types of mechanism, as I told: Laplacian noise, Gaussian noise. Fine. Other mechanisms are there: exponential, but we are not using exponential like that much in FL. The reason being mathematics only. These two things have a standard deviation thing. Fine. Exponential noise, the deviation is different. Plus, these are ideally suited for numerical data. Okay. Thus, these two are used. Yeah. Then we have the thing called as sensitivity. Fine. So how sensitivity works is you already have a data and you are adding noise to it, right? So basically you are updating the data. How much of deviation happens to the data once the noise has been added? That is what sensitivity means. Normal case, the simple idea of sensitivity itself. What is sensitivity in normal case? How much sensitive is a person, right? If I trigger him to a particular extent, when will he start reacting, right? That is what we call a sensitive. Same context applies here as well. Initially there was a data, I added noise to it. How much does the noise affect the usability of the data? Fine. That is what sensitivity is. It is represented using delta F or delta in general. Fine. Delta here stands for the difference. Okay. Yeah. So this is what we call as the privacy utility trade-off. Smaller epsilon means stronger privacy, more noise, less utility. Fine. That goes like this. It's a inversely proportional thing. If you add more noise into the data, right, the data pretty much becomes like purely secure. Okay. Nobody can do anything with the data. Then the question comes is the data useful? The data is not useful. Okay. The data never becomes useful when you add too much of noise. So the idea of DP is to identify a sweet spot where the privacy is high plus the usability is high. Fine. That is what we called as privacy utility trade-off. Fine. So the whole point of research in DP boiled down to this particular point, privacy utility trade-off. Okay. Yeah. So these are the reasons or the rationale how we choose Gaussian DP or like Laplacian DP. Fine. It depends. It doesn't depend upon the direct data type as such. It's more kind of like what kind of gradients are being generated. Fine. Yeah. And there are two types of DPs, record level DP and gradient DP. Okay. Record level DP means you are embedding the noise not into the gradient, but into the localized data. Fine. So when you are embedding data like noise into the localized data, it is record DP. When you're embedding noise into the gradient, it's gradient DP. Fine. In FL, we usually use gradient DP. You will be seeing record DP when you are working with like some kind of normal ML algorithms. Fine. The algorithm is overfitting, just add some kind of noise into it. Okay. Yeah. The next thing is secure aggregation. Fine. In secure aggregation, the fundamental concept is called called as masking. Fine. So masking simply tells you add a mask to the data such that when the mask is getting aggregated, the mask will be vanishing. Fine. Like n number of clients are there and n number of clients are adding mask to their data. Fine. Gradients to their data. Assume it to be like numbers. Fine. I added a mask of -2 value. Okay. I added a mask with a value -2. The person sitting next to me, he basically added a mask with value 2. Okay. Value 2. So during aggregation, -2 and +2 is getting summed up, right? Technically, the number will go to 0. So the mask will be vanishing. That is the simplest way to explain secure aggregation. The question is how closely similar it is to HE. We already know the term HE, right? HE simply means like homomorphic encryption. You encrypt the model, you aggregate the model, right? The primary difference is HE basically encrypts it. Okay. We are not allowed to decrypt the data. Whenever we are working on encrypted data, the model or the procedure becomes too much computationally complex. Fine. Coming to secure aggregation, it never encrypts the data. It just adds a mask to it. Okay. It just adds a mask to it. And computationally, compared to HE, masking is pretty much least complex. Okay. HE and masking compared is secure aggregation any day because computational complexity is pretty much less. Fine. Yeah. So this is the mathematical equation. So when you are like the update here, right? The update here represents your gradient. The mask here represents the number I am embedding. Fine. If I am embedding -2, somebody else is embedding minus like +1. Basically summed up, it becomes 0. Fine. The mask simply vanishes. Okay. Yeah. This slide is a comparison with DP, how much it is like different, how it is similar like that. Okay. Yeah, this is a comparison between secure aggregation and homomorphic encryption. I think we are running out of time. Should we stop, sir? Okay. Yeah. So basically, yeah. So secure aggregation, as I told, it is pretty much different to DP in this aspect. DP uses encrypted data. Secure aggregation just uses mask as such. Fine. So with mask, they'll be computing the data, technically reducing the computational complexity. Okay. So the limitations, primary limitations of DP and secure aggregation. Fine. DP basically gives you very strong privacy guarantee, but the major problem with the DP is how do I identify the noise? Fine. How do I identify the noise? The reason behind that is no system stays in a same manner throughout its lifetime, right? The system will keep on fluctuating. Okay. The situations will fluctuate, the environmental variables will fluctuate. So if a particular level of noise is embedded, we can't ensure that that noise applies to the system throughout the training time. Okay. That is one major disadvantage of DP. So the whole purpose of DP itself is noise embedding, and we are having fundamental issue with identifying the actual amount of noise, and DP becomes too much mathematical. Okay. DP becomes too much mathematical in the sense we need to introduce multiple terms called as ASR, attack success ratio, attack resistance ratio, what is the noise, what is the standard distribution of that everything comes in DP. Okay. So DP is a bit complicated if you are not able to properly calibrate the noise. Fine. The second one is secure aggregation. So it basically hides the data, right? We are hiding the data. We told that secure aggregation and homomorphic encryption, when combined, secure aggregation any day, right? With respect to homomorphic encryption, right? But it's not generalizable. Whenever we are encrypting the data, whenever we are adding a mask to the data, technically the complexity is increasing, right? Because it's not the exact same data, right? I'm hiding it, I'm encapsulating it, whatever I'm doing it, I'm adding something to the data, correct? And that mask need to be removed at some point in time, right? So that basically introduces additional complexity into the data. Fine. That is what happens in that scenario. Okay. Another recently proposed solution or emerging solution is called as KD or federated distillation, whatever you call it. The idea is pretty much old. But in federated setting, the idea is a bit new. Okay. What you do is you have the concept of teacher model and student model. Fine. You have the concept of teacher model and student model. So basically, a model will be there who will be serving as the teacher. In the sense, the teacher will be teaching global model what is to be done. Fine. And there is a student model. Student model basically accepts data from the teacher. Fine. That is the recordical definition. Just keep that aside. Fine. Just keep that aside. As usual, I'm the server. I'm sending my model to you guys. Fine. You guys have finished the training on that. Okay. Once training is done, you will be sending the gradients to me, right? That is the normal data flow. In KD, what happens is you are not sending the gradients to me at all. You are using that gradients and you are basically distilling your knowledge into another model. What do you mean by distill? Distill, transfer, like that. Okay. You are transferring the knowledge you gained to another model. Fine. And that model will now come to me. So the question is, what happens if that model is compromised, right? Possibility is there, but it is not as potent as directly getting your model compromised. Fine. The possibility of the model getting compromised is there in KD as well. But the advantage is that your model is not directly getting compromised. It is a teacher model, right? It is somebody else's model. It is a demo model. So it doesn't matter as such. We keep on fine-tuning the demo model until we get our desired result. Fine. That is how KD operates. Okay. The general idea of KD, right? KD is mainly used in multimodality setup. Okay. Multimodality setup. As we told, the fundamental of federated learning is weight exchange, right? Can I exchange weight using machine learning models? Does machine learning model have weights? Machine learning model doesn't have weights, right? So such a very much celebrated technology doesn't have the capability to incorporate machine learning models, right? The fundamental of federated learning is weight exchange, and machine learning model doesn't have weight, correct? So the question is, does this celebrated technology have the functionality to use weights as such, or like ML models as such? No, it doesn't, right? If I'm using ML models, I need to work out some kind of mechanism which will help me to aggregate. KD is one kind of that mechanism. Fine. The initial proposal of KD was as a cross-platform aggregation approach. Now KD is being explored as a security approach as well. Fine. The next thing is called as personalized FL. Personalized FL. Okay. This is also one emerging research domain, but compared to KD, it's a bit settled one. Fine. So what personalized domain, like personalized FL means, let's put it in a security scenario. Okay, let's put it in a security scenario. Assume that your particular network is having a bandwidth of, let's say, maybe X. Okay, your network is having a bandwidth of X. X plus 1 implies you are having congestion. Fine. X plus 1 implies you are having congestion. She is having a network with a bandwidth of Y. Fine. Y plus 1 implies congestion for her, right? The value of X and Y is different. Let X be 50, let Y be 100. Fine. So can an FL model or can a generalized machine learning model give you exact predictions for you and her? It's never possible, right? It's never possible. Why? Because he needs his network to have the congestion value of 51. She needs her network to have the congestion value of 100 plus 1. Okay. You can put it in medical scenario as well. Okay. The heartbeat of males and females, right? It's different. Correct? I think so. The heartbeats of assume the heartbeats of males and females to be different. Fine. Or BP to be different. Fine. Okay. So when a male is being tested, he should be given a BP value according to his requirement. When a female is being tested, she should be given a BP value according to her requirement, right? Can a single machine learning model do that? No, it can't. Because the requirements are different. The baseline is different. Everything is different, right? That is where personalized federated learning comes into play. Okay. You basically develop or update your model according to the client's requirement, not as a general system. Fine. So it's more like a system inside a system. It's more kind of the what government rule we follow. Our central gives us rules. Each state has its own rule, right? Just take NEP. Tamil Nadu has a different approach on NEP. We have a different approach on NEP. Telangana has a different approach on NEP, right? NEP in the sense national education policy, 3-language system, all those things, right? That is what happens. Same thing happens with personalized FL as well. Based on your requirement, you update the parameters. Fine. Okay. How do you do that? You do it with a combination of personal data plus global data. Fine. Again, I'm repeating, you do it with a combination of personal data plus global data. Personal data plus global data combined gives you a personalized model, right? Okay, the next thing is adaptive privacy. Fine. Adaptive privacy is comparatively a new frontier in FL. People are exploring it, but it's not that much explored. It's still a good research domain. Okay. If any of you guys are like researching in FL, adaptive privacy is a good point to go. But again, it's not a security measure. It's just a privacy measure. Fine. So what adaptive privacy tells is, I will be explaining it with respect to DP because I basically do my research in DP. You can adapt this to any given privacy situation. Fine. Yep. Assume there to be a situation where you are flying your drone. Okay. You have a drone and you are flying it. And it is a long range drone. Okay. Assume it to be having a range of 10 kilometer, 12 kilometer or something. It needs to pass through a city. Then it needs to pass through a mountain. Then again, it needs to reach a city. Fine. Where the drone has higher chance of getting interpreted, in the city or in the mountains? Mountains. No, interpreted in the sense like security based, not physical. Basically, you are flying a drone across a city and across a natural thing. Okay. The drone has a higher percentage of getting attacks in the city, right? Correct. So does the drone need to have identical privacy requirements in the city and in the natural aspect or natural scenario? No. In the city, you need to have or you need to increase the like what privacy of the drone, right? In natural perspective, you need to decrease the privacy, correct? That is what adaptive privacy does. Okay. In the classical privacy, right? Classical differential privacy, whatever we told, they assume every situation to be identical and basically gives the exact same noise value to all given situations. Fine. Coming to this particular context, what they do is they use or they allocate privacy on a context aware manner. You will be familiar with what is context awareness, right? What is my situation? How much I can afford? That is what context awareness means, right? I'm having a particular budget and I'm expected to buy something. I should be maintaining that particular budget, right? That is what context awareness means. Here also it's the same thing. So the privacy is initialized in a context aware manner. Fine. Context awareness includes environment, task, data, every single thing. Fine. That is what adaptive privacy does. Okay. Yeah. So the definition or the task, sorry, like the factors involved are task complexity, data heterogeneity, model convergence, and all those kind of things. Fine. To put it in a very simple manner, you start with a particular level of noise. When there is a chance for an attack to be happening, you increase the noise. When you assume that the situation is neutralized, there is no more attack, you just reduce the noise. Fine. So what happens is you are just allocating the noise in a peculiar manner, which doesn't destroy your accuracy, yet gives you better privacy. Fine. Yeah, how it can be achieved? Through sensitivity aware mechanisms, feedback from utility matrices, and adaptive noise injection schedules or hybrid mechanisms. Fine. So basically, to start with, you analyze the sensitivity of the network. Fine. How much data I can afford, how much data how much noise I can afford, how much cannot be added. That is what comes under sensitivity. Second one is utility feedbacks or feedbacks from utility measures. Utility is, if I have added X volume of data, was the model useful? No, it wasn't. So just reduce the noise. Fine. Then the last one is injection schedules. You keep schedules such that the noise is being injected at X number of time or at X epochs, or either you go for ASR. ASR in the sense attack ratio. Fine. Attack success rate. Okay. So if there is a high attack success rate, you increase the noise. If the attack success rate is low, you just decrease the noise. Fine. Yeah. So this is a general comparison, whatever techniques we told and which kind of attacks do they cater to. Fine. So if you are taking DP, SA, KD, FL, and adaptive privacy, all are basically privacy based attacks. Okay. All are privacy based attacks. If you are working on like security attacks, right, you need to go for something like anomaly detection, intrusion detection, those kind of things. Fine. That is what works for security attacks. These ones are limited to privacy attacks only. Okay. Yeah. And this is a general comparison of how much. This one is more kind of a research question. Okay. It's not for like UG category people. Research people can make out of it. Fine. Yeah. And the last thing is, yeah, I'm just winding it up. So what do I do basically? So my research is mainly into these kind of stuff. We do federated learning. Yeah. Previously, I was working on fundamental aspects of federated learning. Now we specifically focus on critical infrastructure systems. Yeah. You are familiar with what critical infrastructure is? No? Critical infrastructure. Yeah. Nowadays, the warfare, right? Warfare. Previously, it was more kind of a physical warfare, right? Or compact warfare, we say. Contact will be there between both parties, right? Nowadays, warfare has changed entirely, correct? Whenever something happens between India and Pakistan, right? What do they do, or what do we do? Basically, hackers attack their websites first, right? Hackers attack all their official websites. That is step number one. Step number two is attack something in the cyberspace. Space. Attack something in the cyberspace. That is what they are doing, right? I'm not sure how many of you already know it. Are you familiar with the Ukrainian blackout? No? Ukrainian blackout, no, right? Yes? Yeah. So basically during the Russia-Ukraine war, right? Russian hackers or whatever you want to call it, they basically blacked out the electricity of Ukraine 2 times. In the sense, whole country was in black. Like whole country, they had no electricity, nothing. How do they do it? They use attacks. Fine. They use cyber attacks, which will take over the control systems, and then they will black out the full electricity for the country. Power system is one kind of critical infrastructure. Second one is like electricity generation, turbines, those kind of things. Another one is nowadays an emerging domain, that is UAVs, unmanned aerial vehicles, those kind of things. Fine. So my research as of now is mainly focusing on that. We simulate these kind of attacks in power grids, UAVs, and we try to devise solutions for that. Right? Sir, should we go for hands-on? First? Okay. Yeah. So I'll be just winding up with this. If you have any questions, please. Yes, and we are always open to collaborations. Anybody want to collaborate, just ping me. Fine. If you are working in any of these domains like federated learning or like security, AI-based security, malware detection, IDS, UAVs, anything, please feel free to ping me. Okay. I'll be available through mail or like you can catch up with in LinkedIn. Fine. Yeah.
Sure. As you mentioned, like for secure aggregation, the homomorphic encryption is best method. Why you prefer homomorphic
Yeah.
encryption rather than any other encryption method? Which
Yeah,
are,
that's a good question, but off context. Why? Because the fundamental idea of FL, right? This one is for IoT devices. Okay. You're having your mobile, you're having some kind of, let's say, Raspberry Pis, something like that. Fine. You're familiar with the Raspberry Pi, right? It's a small kind of a CPU kind of thing. Fine. The idea is lightweight devices. Coming to homomorphic encryption, assume a simple question. Okay. You're having to do summation operation. 1 plus 2 equal to 3. How hard is it? Can it be done in polynomial time or it can be done in linear time? 1 plus 2 equal to 3. I can do it in linear time, right? Same question, you convert it into encrypted data. 1 is encrypted, plus is encrypted, 2 is encrypted, equal to 3. Everything is encrypted. Can it be done in linear time or polynomial time? It will go to polynomial time. Simple question. 1 plus 2 equal to 3. Why do I need to complicate it that much? Right? That is for simple arithmetic. Okay. Now change this and assume it to be model weights. How big it will be? The parameters will be 2 million, 3 million, 1 million, 10,000. Even in worst case, also 10,000 parameters. So the complexity is not increasing linearly, but exponentially. Fine. Yes.
And I have one more, sir. As you explain about DPE,
Deep.
DP, differential
Ah, okay.
privacy. Okay, sir.
Yes.
Sir, you are saying that data was modeled with private noise, means noise.
Yes.
So when you're trying to train a model with the noise, in case of scenario, the noise data will be in context with two scenarios, sir. Might be possible. So if it has happened, how could the trained data will take, whether it's compared to this scenario or that scenario?
Yeah. Okay. So the question is, if I understood it correctly, when you are training with the like noise, the noise can go in both directions.
Both directions.
Okay. So the thing is, we already told something called as utility, right? We have a usually, I forgot to keep it. We have you are familiar with the bell curve. Okay, bell curve means it goes like this and comes down. Okay. You have pen is there. Okay. You have something like this bell curve. Okay. So basically this depicts the whole setup. If you are specifically looking into DP, we will be looking onto something called as, there is something called as ASR. Okay. Attack success ratio. I personally work on adaptive DP as such. That is why I'm specifically mentioning this term ASR. So what I do is I simulate an attack. Fine. I simulate an attack and the system will be having an IDS or intrusion detection system or attack system, whatever you want to call it. So there will be a trade-off where the system is expecting an attack to happen. Fine. When the system is expecting an attack to happen, he will increase the noise. The attack will be neutralized. After some time, he'll be decreasing the noise. So again, there is a possibility of attack happening. Fine. That trade-off will keep on happening in DP. So like if you are working on adaptive DP, only inject noise when it is required. If you are working on like standard DP, right? Standard DP means you will be coming on to like multiple approaches are used. One approach is you come into an understanding between the sender and the receiver. Okay. Receiver is telling or the client is telling, okay, just keep in mind that I am attaching 0.5 volume of noise. Or like put it numerically, fine. I'm expected to send 100 to you. I'm already telling you. Like to trick someone, I'm just telling you, just think that I'm sending you 200. But you already know that you are expected to get 100 only. So you'll be just reducing the 100 and then you'll be getting the actual data as such. Fine. That is one method which is generally used.
Sir, then if you said that DP is only concerned about privacy, sir.
Yes.
Then if you, in this case, if you want to make sure that it depends upon intrusion detection
Yes.
system, you said. So we have to separately have another means privacy security based system for it, or can we do it?
Right. So basically, DP alone can't detect attacks. In the adaptive privacy, right? Adaptive privacy is more kind of a very advanced term. Okay. Still research is going on. So what we usually do is we'll have a dedicated mechanism which predicts attack happening, but it won't be fully fledged IDS. It won't be a proper IDS. It will be some kind of mechanism which identifies the triggers, not the full attack. Fine. So if you are taking like heart attack, right? Before heart attack happens, you will be having like sweating or you'll be having some kind of uncomfortable feeling, right? I'm not technically detecting heart attack, but still I'm able to know that. Those things are called triggers. So those models will be detecting the triggers rather than the actual attack. We are preventing the attack from happening. IDS is attack has happened, I'm detecting the attack, right? So that difference is there. Fine.
Thank you, sir.
Sir, online participants
Yes,
also.
sure.
If anyone is having doubts, please unmute and come forward. Or you can come in the chat also.
And nobody is asking questions, right? Two possibilities are there, but not like madam told. Yeah, okay, sorry. Yes. I take it like either my class was really good or it was so bad that nobody want to ask anything. Yes. Any more questions? No. Yeah. So that is my mail ID. I'll be available in LinkedIn. Just feel free to ping me if you have anything. Okay. Yes. Okay, then thank you.
Thank you, Dr. Akash Kinair, for the enlightening session on privacy preserving using federated learning. Your deep insights into federated learning frameworks and practical applications is ensuring data privacy have provided us with a clearer understanding of this crucial area. We truly appreciate your time, effort, and valuable contribution to the success of this FTP. Thank you, sir, once again. Yes.
Ma'am, could we get the LinkedIn of the sir?
Sure.
Yeah.
Once again, he'll share you now. Hello, the LinkedIn, it's being posted in the chat. Okay, you can receive it from the chat box.
Thank you, ma'am.
Okay. Good afternoon, one and all. Cybersecurity is much more than a matter of information technology. With this thought, we now move on to our final session of the FTP, which is on malware detection using machine learning techniques. The session will be handled by Dr. Kanchan Lada Kashyap, Assistant Professor in the Department of CSE Cybersecurity at IIIT Kottayam. Ma'am has completed her PhD from IIIT DM Jabalpur and brings with her 18 years of valuable teaching experience. Her research interests spans image processing, mesh-free approaches, machine learning, and natural language processing. She has published 36 papers in various SCI journals, international conferences, and book chapters, and has successfully guided 2 PhD scholars. In addition, she serves as a reviewer for several reputed SCI journals and IEEE conferences. Without further delay, let's warmly welcome Dr. Kanchanlada Kashyap to begin with this insightful session. Over to you, ma'am. Thank you.
Okay, thank you, Tamsi. Thanks for the introduction. Today it's a last session. It's not that much difficult. I have actually easy introduction I will give about the malware. Then how we can analyze the malware or how we can detect the malware with artificial intelligence. Okay, so I will start with that basic one, then slowly we'll move towards that artificial intelligence, right? So basically that first, what is malware? Just a minute. That it's not moving actually, slide is. Yeah, okay. Through this it is, yeah, it's fine now. Yeah, okay, okay. So as I told you that the today's agenda is first we'll discuss about the various types of malware, and then malware analysis techniques, malware detection techniques, and then what are the various machine learning techniques that we can apply for the malware detection, and then what are the various deep learning techniques that we can apply for the malware detection. Okay, and then some hands-on session if time permits. Yeah, I'll try to finish it for the 30 part because I know that everybody, they are eager to see the hands-on. So what is malware? Anybody can tell that? What is malware? Everybody, we all are aware about the, what is malware. So what is malware? Malware is nothing but that malicious software. Okay, so what is the intention of the malware? Can anybody tell me that? To uh, yeah, various intentions are there. The malware that we'll see in that upcoming slides. So basically, that malware is nothing but it is used to design to harm the user, computer, network server, or client. Okay, so various kinds of softwares, various kinds of the malwares are there. That virus, Trojan horse, rootkit, scareware, spyware. We'll see that some more types of that malware. Now, every day, approximately, we can see that 3 million new malwares are created by hackers. Okay, so that's why that malware detection is a very challenging task, because how we can detect that zero-day malware attack. Okay, so that thing we'll see. So what is the intention of malware? That everybody know that malware it can delete our sensitive data, our confidential files. It can steal our confidential information like user ID, password. It can encrypt our data. So by using some file modification calls, and it can encrypt that file, and it can ask for the some ransom amount to get the decryption key. It can multiply and spread the malicious software. It can monitor the user that what we are doing, okay, by active users and processes. Same way, it can alter or hijack that core computing functionalities by using system calls. It can stop the services and shut down the system, and it can give access of our computers to that hackers. And obviously, that it will send that it can gather the information, and it can send that important information to the attacker. So the intention is that to harm to the user, to harm our computer system, to harm our our network system. Okay. So various types of malwares are there. You might have heard about all these kinds of malwares. That virus. Okay, so virus is the most popular one. So first virus it came, that is a I love you virus in 2000. Okay, you might have heard about this. So actually it infected the millions of computers through email attached. Okay, so basically that it attached itself to the program, and it infect the devices. So this is a very popular kind of malware, we can say. Then worms, again, it can self-replicate it, and it propagates its copies to other devices over the network. So Stuxnet and that Morris worms, it comes in 1988. Trojan are there. That is a kind of that backdoor. Actually, it looks like a legitimate software, but it contains some malicious software, and it get installed. Okay, once we'll install the legitimate software, along with that it get installed. So ransomware, basically that it will lock down our files, and it will just ask for the some ransom amount. So this ransomware that it comes in WannaCry. WannaCry is a popular ransomware attack. It comes in the 2017. CryptoLocker is there. It comes in 2023. So various attacks already has been done. So backdoor, it again it allows the unauthorized access to the functionality. Bot is there. That is a very popular one. It will distribute the malwares to other devices. Keyloggers are there. So suppose we'll type some password or something, so they will they will just try to store that whatever the key we are pressing. So it will just the keylogger motive is to just steal the sensitive information. So rootkit is there, again it will gain access to that files and systems, and that will exist in the malware. Logic bomb is there, so based on the some condition it will explode. So adware is there. Nowadays whenever we'll work with the internet, every time that adware comes, so that adware is nothing but it's based on the advertisement that malware comes. So spyware, that will again monitor the user activity and sells their data to the malicious actors or hackers. That Pegasus, this is it comes in 2021, that is a spyware. So mobile malware, now it will target that our mobile devices to steal and spy and damage our files. So these are the various types of malwares. And what are the various natures of malwares? Okay, because malwares cannot be, we cannot understand the malwares easily. Okay, although it's a software, but it has a various natures. So because of that nature, we cannot easily understand that those softwares. Okay, so we'll discuss about that various characteristics. So it will define the functionality of that malware. So one is that obfuscation. So obfuscation means that it will hide that something, some meaning will be hidden. Okay, so that we should not, or we cannot understand that malware properly. So it will use some encryption or compression techniques to hide that proper code. So it contains that payload delivery. So payload delivery basically, again it just payload, it will be added to steal the sensitive information like some login credential or some financial data. And then command and control. So malware basically it wants to that communicate with the remote server. So you want to take that control of that remote server or that command and control infrastructure, and it will try to communicate. And then self-replication, that again we know that virus and that worms, that is self-replication. It will just it has the ability to self-replicate itself, and it can just spread across that our, because nowadays we are using internet, we are just connected with that network. So it will just try to spread itself through the network devices or files. Okay. Then that exploitation, what is the nature of that? It want to exploit our files. Okay, some vulnerable files are there, some vulnerability is there in our devices or files. So it try to exploit those weakness point or those loopholes. So that it can exploit whatever our some flaws is there in that our security, that is a loopholes or vulnerable point is there, that it will try to exploit. And polymorphism, so polyformic, that malwares are polymorphic in nature. So it will change dynamically its structure and its appearance. So it will be difficult to understand that malware. Okay, whether it's a malware or which kind of malware are there. And obviously that ransomware, as I told you, that ransomware basically it will ransomware, it combines a cryptography with malware. So it just use the encryption techniques and it will lock our file. Okay, so obviously you might be knowing about the encryption and decryption techniques. So to encrypt the file, some key is required, and for decryption the key is required. So it will encrypt, and it will encrypt that file of the user, and suppose user tried to open that file, the decryption key is required. Okay, so that is to disclose that or to give the decryption key, it will demand for that cryptocurrency. Nowadays it's a cryptocurrency, they want some amount. Okay, so that is a popular one nowadays, that ransomware. Okay, so these are the various natures of malware code. And another one is that what I mean, who will be the target of that malware? Okay, so some based on this one, so some malware are mass malware, so they will just try to infect the many systems, many machines as much as it can infect. So this malware, this mass malware is the most common type. And this uses the well-known vulnerabilities. Some loopholes are there in our files, our systems, our networks. They will apply those loopholes. Okay, and attackers are not that much high skill. They are average skill. So that one of that mass malware, that is a WannaCry. So they have targeted to many machines. Another one is a targeted malware. So it will be just developed for a specific target. They don't want to just infect that many machines. Okay, so the target will be some popular people or popular personality. Okay, so what they will do that, just they try to gain some financial, some monetary things. So that one of the example of this is Stuxnet. That is one of the example of targeted malware. So they uses a 0-day vulnerability. So that's why it is very difficult to detect, prevent, and to remove. So another one is that how that malware get spread, at what type, what kinds of file they use. Okay, so malware can be any executable file, that exe file or batch file or some app file, okay, or shell. So or malware can be attached in some PDF or Word file or Excel file, that is a micro code we are using. So that in with that they can attach in that PDF or Word or Excel file. Or that malware, that hackers can attach that malware in the web script, okay, in the website or web end script. So they can attach, and with the help of those, they can spread that. So nowadays that they're using the multimedia also, that images and video, music. So malware file can be a variety of malwares or variety of files we can found. Okay, we can find that. So this analysis of malware, that's why it's tough to analyze that. That is a very challenging task. So earlier, nowadays also we are using this. So basically, we have to analyze that malware. So uh, that so that why the malware analysis is needed. So basically we want to just understand that what is its functionality, how it works, what is the type of that malware, what it wants to do, okay, what is that intention of that malware. So with the help of that malware analysis, that we try to collect that intention of that malware. Okay, so whether that whether we can see that whether they are collecting the information from our system or our network, or whether that malware is trying to communicate with anyone in the internet, or it tries to encrypt our file, because based on the various natures of that malware, it will do some task. Okay, so will some functions it will perform. So we'll try to check their functionality. Okay, whether it will attempt to stop any services, or it will create or delete any files, or it will just look for some database server or email server. So basically that with the help of malware analysis, we can just find out what is the intention of the malware, whether it's a mass malware or it's a targeted malware. So why we'll do this analysis? So that we can improve our defense system. Okay, because daily, as I told you, that various malware they are developing and they are spreading. So we have to understand what is that nature of the malware, okay, what they are trying to do, so that we can improve our defense system, so that we can improve our file, our computer, our network, our devices, we can protect. Okay, so basically that by using this by the analyzing the malware, we can just create a signature of that we can understand the pattern, or we can collect the signature of that malware file. Okay, so we can just know that what is a file type, what is file name, what is the registry, so registry key. So we can collect the information, and we can just collect the signature or their pattern. Okay, so basically that this is very popular malware analysis, that is a static and dynamic. So static and dynamic malware analysis, we can analyze the malware, the various functionality of the malware, and we can collect the various information. And those information we can apply in the machine learning technique. Okay. So what we can do that, first we can go for the static analysis. What is the meaning of static analysis? We'll see in the, briefly, and what kind of that features we can collect, okay, with the help of that static and dynamic that we see. So for the static and dynamic malware analysis, this PE that is known as a portable executable file format, that is very important. Okay, so we can collect many types of that information with the help of this PE PE file format. Basically, this is a most common file format for executables on Windows platform. Okay, so what it contains, basically, most of the malwares are written in that Windows and all are in that form of that .exe and DLL. All are the PE files. Okay, so basically it contains that functionality of the malware and how it interact with the operating system. Okay, so basically PE files, it contains the two things, that is a header and sections. And again, when we'll explore, when we'll expand this header and section, so header section again contains the MS-DOS header, PE header, optional header, sections tables, many import and export address tables. And that section means code section. So code section contains some data section, that the different text section, our variable sections, so our memory address section. So basically with the help of this header and section files, we can collect various information about the malware. Okay, so actually I have not taken the detailed one. Again, some detailed information about these header sections are also there in that P executable files. Okay. So, so this P executable file is very important in that static and dynamic analysis. So, what is that static analysis? Basically, that static analysis, as the name says, it's a code analysis. Basically, we don't execute that program. So, without execution of the program, we'll analyze that malware. Okay, so that's why its name is static. We don't execute that, we don't run the program, and by just seeing that code, we can analyze that. Okay, so what we'll do with this static analysis? So basically, we'll extract the useful information from the suspicious binary files without running it, as I told you. So we can see the functionality of the file, and we can make a signature without executing that file. So that signature we can use to predict that whether the file is a malware file or it's a normal file. So basically, what we do in that static analysis, we'll analyze that, as I told you, that PE file. We analyze a PE header and section file. So it will gives us that information about the various linked libraries, because the malware will be linked with that various libraries. So it will just we can just get the information about that, what kind of libraries are there they are using, what kind of functions they have imported and they are exporting, and that various these files, that link libraries, and that these files, it will contain the various metadata about that executable. Okay, so this will analyze with the help of this static analysis. So same way that it will contain some strings also. So what kind of strings we can find that URL, because it will try to access some other devices or some other resources or some other network. So we'll try to get that URL, domain name, IP address, name of that loaded DLLs, and some registry keys. So these will become the features, okay, for our machine learning techniques. And some suppose that file is our encrypted, then we'll try to get that whether they have given some encryption code. So what kind of encryption technique they have applied. Okay, so by using that encryption techniques, how they are manipulating the code. Okay, so this is a very actually challenging task, that because with the help of encryption techniques, they can just manipulate, they can change the file. So this thing we can analyze. So this we can find with static analysis. Okay, and then we can go for the reverse engineering or disabling the program. So what we can do that, we can translate, because exe is a binary file. Exe is a binary file, so we can translate that binary file into assembly code. Okay, so assembly code we can understand. Binary file, it will be tough to understand, but when we'll convert the machine file into assembly code, easily we can understand that what function they are doing. So we can just load the executable into disassembler, and we can translate into assembly code, and we try to understand that malware file. So static analysis, it is used, we perform without executing that code. So normally this kind of features we can extract with that static analysis, that structural properties of the files, that is entropy. So obviously that if malware file will be there, then entropy will be more or randomness will be more. Okay, so if entropy value will be high, then obviously that it may be a malware, or file may be encrypted, or we'll see that whether it's any compression has been done or not. So code analysis, with the help of code analysis, we can find that function calls and that code blocks, code patches. So how they are calling to functions and how many functions they are calling. So with the help of that graph, okay, with the help of that block graph, code graph, we can analyze that that file, and that file header, file extension also we can get, and some string also we can extract that, as I told you that whether the malware will contain some uncoded strings. So file name, file path, some libraries, so URL, IP address, this I have already told you. And when we'll go for the disassembly of this file, so we can just know about the various function calls, API calls, and system calls. So all these features we can extract with the help of static analysis. So various tools are available that if you're interested, we can use these tools for the static analysis. That is a virus total, hashclack, HXT, Xinfo, PE, BinText, and then PE Studio. So when we'll start with that static analysis, so we can use any one of these tools. Another one is that dynamic analysis. So basically that, as I told you, static analysis, we don't run that malware, but in the dynamic analysis, we'll analyze that malware by running it. Okay, so we'll check what is the behavior of the malware. Okay, so how we can check the behavior of the malware? We have to execute that. So once we'll execute the malware, how we can execute that malware? When we'll execute it in our system will get collapsed. If our system will be connected with that network or other system, obviously all our network will get collapsed. Okay, so for this dynamic analysis, actually we have to perform in a safe environment. Okay, so what we can do, that we can just use that some physical machine that will be isolated with the network. Okay, that will be disconnected with the internet, and so that we can prevent to spread that malware. We can use virtual machine, or we can use that sandbox. So all these are available that we can use for the dynamic analysis. So automated malware analysis sandbox are already available. That is a McAfee, a Wildfire, Cuckoo sandbox. That is a very popular one. That is open source sandbox, and any.run. Okay. And some malware analysis tools are also available. As I told you that to run that dynamic analysis, that sandbox is required. Okay, that virtual environment, so that we can use. And for the dynamic analysis tools, as the static analysis tool, the dynamic analysis tools are also available. That the process explorer, auto run, process monitor, Rakshot, these are the various popular dynamic analysis tools are there. So what will extract with the help of this behavioral analysis? So obviously that our program will contain the various API calls, various system calls. So we'll trace that what kind of API calls they are using. They have used file integrity check. File integrity check, that it will tell us the authenticity of our file. Okay, so if file is not authentic, obviously that the FIC will be wrong. Okay, so we'll analyze that various environmental variables, that local, global, what kind of variables they have used. What is that memory and registry entries are there? Okay, so if there will be malware, obviously that memory and registry entries will not be normal. And that what kind of system calls that hackers they have used in that malware, and what is the network traffic. Okay, so all this will analyze with the help of this dynamic analysis. So basically that based on this static and dynamic analysis, that various detection techniques are there. So first one is that signature based detection techniques. So as I told you that we have to check the pattern of malware with the help of this static and dynamic analysis. We'll check what is the pattern they are following. Okay, so we can just collect the pattern. So pattern is nothing but the signature of that malware. So that we can collect, and then we can just we can just store that pattern. Okay, and if new pattern will come, or and then that malware signature will be nothing but it will be a it will be an algorithm, or that will be a hash that will uniquely define that particular virus or particular malware. It will be a hash or signature, we can say, or pattern, we can say, anything we can say. So this normally initially that antivirus software, they are using this signature based detection techniques. So what is the problem with this in that intrusion detection system or prevention system or firewall system? It is based on rule. We are just checking the rule whether the new coming software or new software, what is the signature of that new malware. Okay, if it is that matching with the existing malware, then we can say this is a malware. But suppose that 0-day malware will come and we don't have the signature of that malware, that we don't have what is the pattern of that newly created malware. It means that this IDS or IPS system, IDS system will not be able to detect that 0-day malware. Okay, because whatever the rules, we have already known that patterns, based on that pattern, we have created the rules. Okay, but for the 0-day, that pattern is not available. Okay, so it will be difficult to detect that 0-day malware. Okay, so that's why that another one is there, that is a behavioral based technique. So it will observe the behavior of the PE file. As I told you, it's very important files, and to conclude whether that malware is a malicious or not. So the program with that same behavior will be collected. Okay, and then we'll analyze it dynamically. We'll check their malicious behavior. Okay, and then we can say that it's a malware. So if their behavior newly coming software, if the behavior will match with that behavior of that already we have done, then we can say that this is a malware. So it can deal with the unknown malware, but at the same time it will also generate that false positive. Okay, so that is that problem with this behavior based malware. So now another approach is there that uses the data mining and machine learning techniques. So that is known as a heuristic based approach. Okay, so as I told you that various features we have already extracted with the help of that static analysis and then dynamic analysis. So those features, that API or system calls, n-grams, control flow diagram, by analyzing that code, that various opcode, we have already changed that binary code into assembly code. So when we change the binary code into assembly code, we'll get the opcode. So all these features we can extract with the help of static and dynamic malware analysis. So and automatically we can, so in the machine learning model, we'll just perform the training and testing. So we'll train our machine learning model with the help of those features, and then if new malware will come, then automatically it can detect that. So nowadays that all the antivirus softwares, all the IDS, IPS system, they are following this machine learning techniques or heuristic based model. So we can save our time. Okay. So now we'll see that what is that ML based malware detection and classification technique. So as I told you that in machine learning, everybody, you all are familiar with the machine learning, something that how it works. So machine learning, various that I have covered that. What are the various machine learning techniques are there? So basically that two phases will be there in the machine learning. First, we'll train our model. Okay, first we'll train our model, that is known as the training phase. So during training phase, we'll give that benign executables and malicious executables. So what we can do that I mean, there are different kinds of classifier or different kinds of input we can give. First one is that raw binary classifier. So directly we can give that byte content from the executables as an input feature. Okay. Or what we can do that we can extract the various features by using the static and dynamic analysis, and we can give those features for training of our model. So two things we can we will see the example of each of the things. Okay. So first we'll train our model with the help of this benign executable or malware executables, and then by using the training, and then that will just train our model, and we'll use this model for the testing one. So this predictive model, it will just will give some unknown file for the testing one, and this trained model will give us that prediction whether that test file is a benign file or it's a malicious file. So basically two things will be there. First part is a training part and second part is a testing part. Okay. So how we'll perform this this training and testing? So for any kind of machine learning techniques, training and testing is required. Okay, so we'll see that, and obviously for the training of machine learning model, lots of data will be required. Okay, so lots of that benign files and malicious files, as well as that lots of features will be required. Suppose we'll go with that feature level classifier or feature based classifier. So we'll have a more number of features so that we can train our model and we can test our model perfectly. Okay. And same time, we have to update our model also. It's not like that once we'll train the model and we can use that. How it will automatically detect that? Time to time, we have to train our model with the new malware and new benign files. Okay. So that our system should be updated. Okay. So I don't know, I think some of one of the lecture already done with this machine learning techniques, that supervised and unsupervised machine learning techniques. But at least just a review one, I'll give that. What is a supervised machine learning techniques? That we have, we must have that label data. So when we give that files, binary files, so we must know that this binary file belongs to malware and this binary file belongs to that benign file. So data must be a labeled one. So obviously, how we can, suppose you are a layman, we don't know that you are not a cybersecurity expert. So how we can label that? So that is a challenging task. Okay, so if the cybersecurity expert will be there, they can analyze and they can say that these files belongs to that malware and this file belongs to that benign. Okay, same way when we'll extract that features from that benign and that malware file, then we have to carefully label it. All these features belongs to that malware features and all these features belongs to that benign feature. So labeling of data is very important. So if we, and how we can label that data? While the data collection, first we have to collect the data. After collection of data, we have to label it. So carefully, with the help of the expert only, we can do the labeling of that data. Fine. So if we collect the wrong data, so obviously our training will be wrong and it will give us the wrong result. So for the supervised machine learning techniques, that label data will be required. Okay, so various various algorithms are available, and what we'll try to do that, we'll just find out that relationship among the variables. Okay, and that output, that we'll try to find out. So detail, I don't know whether you have already studied or not, but detail we cannot cover. Many algorithms are there. So that algorithms that we can apply in machine learning, so they are again linear regression, logistic regression, k-nearest neighbor, so support vector machine, decision tree, random forest, neural network. So all this comes under that supervised machine learning technique. So for all this, that label data will be required. Okay. So any doubt till now? I have not asked with that those who are online. So can I proceed? So these are the very basic things. Already, I think you have already covered this thing. Another one is unsupervised machine learning techniques. So for this one, the labeled data is not required. So what will do that? Some unlabeled data will be there, and we can just find a pattern. Okay, with the help of that mathematical model, with the help of some distance measurement, we'll try to find that a similarity of that files. If more than one malware file will be there, so they will be similar to each other. So their property will be similar to each other. So if the property will be similar, so how we can measure the similarity? With the help of some distance measurement. You might have heard about the Euclidean distance, Manhattan distance, very checkerbox distance. So with the help of various distance measurement, we can measure the similarity. If two features will be similar, exactly similar, so obviously the distance will be 0. But it will be similar to that, then distance will be very less. But the features of the malware will be different with the features of that normal file. Okay, so the distance will be more. So all the malware having the similar property will make a one cluster. Okay, and all the malware having that, all the file having that, all the normal file having the same property. So it will create another cluster. Okay, so with the help of this unsupervised machine learning technique, that unlabeled data will be required. If you don't, if your data is not labeled, so with the help of this unsupervised machine learning technique, we can just find a correlation among the features and we can make a clusters of malware files and then normal files. Okay, so what we'll try to do that, we'll try to find out the pattern. What is the pattern or hidden pattern of that malware features and hidden pattern of that normal features. So various unsupervised machine learning techniques that we can apply in for that clustering of malware. That is a k-means, that is a very basic and popular one. And hierarchical based clusterings are there. Density based clustering technique, that is a DB scan. Okay, various other clustering techniques are there, but these three are very basic one that we can apply. So as I told you that we can make a clusters. So here these are the clusters of that already human has been annotated. A cyber expert has been annotated, and these are the new one. This green and that red color. These are the new one. So when we'll apply the clustering technique, some of the features will be similar to that already that malware file. Some of the features will be similar to that normal file. So based on this similarity, we can create a cluster, okay, of different files. So nowadays it's a era of deep learning. So for the machine learning techniques, we have to manually extract the features. Okay, as I told you that our classifier may be in that raw feature-based classifier, or it may be a binary raw binary classifier. Okay, so the deep learning model, no need to manually extract the features. Okay, what we can do that, we can just convert that malware into image. Okay, so because malware contains a binary file, that is in terms of 0 and 1. So we can just convert that binary file as an image. Okay, and then we can directly either we can directly give those images as an input to the deep learning model, or from those images we can extract the various image based features. I have shown in the detail. Okay, that we'll see. So various image based features are there, like that gray level co-occurrences matrices, local binary pattern, wavelet. So various taxer based features are there, DCT, Gabber based features are there, because it will be a grayscale image. So when we convert the malware into that binary image or grayscale image will be there. So from those images, we can extract that various features and we can give those features to the machine learning model for training and testing. Or we can directly give those grayscale images to the CNN model or deep learning model. Okay. So various authors, they have already applied this CNN deep learning based model, CNN model, LSTM, RNN, and some transfer learning based models. They have also used that VGG19, inception, exception. So this reference I have given, it's a survey paper. You will find that various authors, they have used that various deep learning model. So if you're interested for the research work, you can do that. It's a very nice paper. It's a 2024 paper. So various techniques that various authors, they have applied for the malware detection by using the deep learning models, that it is given there. So I have taken from this reference. So actually that in that LST model, we can use this attention based mechanism also for the malware classification. What kind of malware is there? And that deep learning techniques we can use to detect that cryptographic ransomware. Okay. So already many papers has been published to detect this cryptographic ransomware. That if you're interested, you can go through that in detail. And now that explainable AI for the malware detection, because why explainable AI? Because the deep learning model, it's a black box model. Okay, how we are getting the result that we don't know. So that with the help of the explainable AI, we can say that because of this feature, we are getting this result. So we can include that explainable AI also in the deep learning model for malware detection. So all these are very popular techniques or advanced techniques that nowadays researchers are using. And that natural language processing also we can apply for the malware classification. How we can apply the natural language processing? Because that malware contains that various executable files, that word file, macro file, and logs from that various operating systems, email, and various network activities. So it contains some strings. Okay, it contains some text. So what we can do that we can just collect those text, those strings from the malware. Okay, and then we can create a, we can just create our the data set that will be a strings data set. But that the problem with that text is how we can convert the text into numbers, because machine learning takes the value is a numerical one. Okay, machine learning we give the numerical value only. So what we can do that we can apply the various natural language processing tasks. So first task of the natural language processing will be text encoding. So what will do that in the text encoding? Many redundant code will be there, many comma or missing value, many semicolon or at the rate, many unused full text will be there. First, in pre-processing task, will just remove those unused letters, okay, unused text. So we will just extract that some important keywords, okay, some redundant keywords will be there, then also will remove. So all that important keywords only will collect with the help of this pre-processing, that is known as that tokenization. Okay, that is known as the tokenization, removal of the redundant keywords or some that unnecessarily words that will remove. So we'll go with the text encoding. And then what we'll do that after that, we have to convert that text, that tokenized text into vector form. Okay, because machine learning, we have to use that numerical values only. Okay, so some various text to vector conversion techniques are already available in NLP. That is a bag of words, term frequency or inverse document frequency matrix, that is a TF-IDF. Hot encoding, that is also very popular, ASCII representation or word to vec. So all these are techniques by which we can convert that our tokenization part or that collection of text into that vector one. Okay, so various techniques are there, and after that vectorization process, we can give that vector that has been converted into numerical value to the classifier. Okay, so various machine learning techniques also we can use, or CNN or LSTM models that also can be applied. Okay, so it's a natural language processing also we can use for that malware classification. So this I have already told you that various features we can collect, that various static features or dynamic features. And this static and apart from this static and dynamic features, that is strings or byte engrams, opcode engrams, and then API function call, image based entropy features, function call graph, control flow graph, and then memory and registry uses, then instructions, network traffic, API call trace. We can collect all those features, as well as we can use some log files also. Okay. So this log file, system log files, timestamp, device ID, message number, message text, authentication log, local security logs, network access log, process ID, user ID. All these features we can collect and we can use for the machine learning model, for training and testing of machine learning models. Okay. So this thing I have told you, these features we can directly give these features to the machine learning model. Okay, and then some for the data preprocessing is also required. There is some steps we need to follow. Data preprocessing will do, some data exploration also will do, and some data normalization also will do. So suppose the range of that numerical value will not be equal. some value will be in that terms of 0 and 1, some value range will be in that between 1000 or above 1000. So we have to go for the data normalization also. That is a that comes under pre-processing part. Suppose we want to go for the dimensionality reduction, then we can reduce the dimensionality by using that various dimensionality reduction techniques, that is ICA or PCA. Various dimensionality reduction techniques are available in the machine learning model, that also we can apply. Okay. After that, we'll get some reduced feature. That feature we can apply for training and testing of our model. Okay. So that is one thing. Another thing is that, as I told you, that we can use that various images for the malware detection and classification. So what we can do, that various that malware data will be there, that malware data will be the binary input. So we can convert that malware file into grayscale images. Okay, so various malware having the various grayscale images, I will show you that how we can represent that thing and how it will look like. Okay, so this binary input will be converted into this grayscale images. And as I told you, that we can apply some normalization technique or some image processing techniques, and then we can extract the various grayscale feature, because it will be a grayscale image. Then we can accept the various grayscale feature, that if you are aware about the image processing techniques, then various texture-based features are there: local binary pattern, gray level co-occurrences matrix, that wavelet feature, DCT feature. All these are based on the grayscale feature or texture-based features, we can say. We can extract those techniques, those features, and we can apply the machine learning model. We can apply those features to train our machine learning models. Okay. So you can see that various sample of the grayscale images of malware families are there. I have given the link of those data set also. If you are interested, you can use that. So Ramnit is a very popular one. That is a malware that it is used to steal the sensitive information like username and password. So we can see the difference of these images. So Rabnit having the different grayscale, and then Lollipop, that is a malware. That is a Lollipop is nothing but adware. Normally, when we'll use some internet, there's some ad come. Okay, so that is nothing but they are giving the lollipop to us. So that window, that is Trojan. Okay, so we can see that the texture of different images are different. Okay, so when we'll use a different texture based features, so obviously that texture features of different malware will be different. And by using those texture based features, we can classify that this image belongs to that what kind of malware. Okay, so here we can see that another images are also there. That is a SIMDA. It's a backdoor malware. It can steal the sensitive information. Tracker is there. That is a Trojan again. That it will hijack the results from the different search engine, Google, YouTube, Yahoo. Okay, so we can see that various malware having that various texture. Okay, so manually also we can see. So now again that obfuscator, Gatak. So these are the various families of malwares are there, and that we can use for the malware classification. So if you are interested, that image data sets are already available for your research purpose. Just you want to experiment this, you can use this mal image that it contains a 9342 number of sample images, and the classes is 25 types of malware are there. And big 2015, it has a 9 number of malware. Ember is there. So already that they have extracted the features from the PE files. So it has the 18 type of malware. Blended, basically they have just malvis and that mal image. They have just integrated both the things, blended, and it contains a total 31 features, 31 types of malware. Okay, so all these data sets are available. It's a publicly available data sets are there. If you are interested, you can use those data set. So as I told you that how we can use this for the malware detection or for malware classification. We can just give that input malware images as an input, And as I told you that either we can apply we can extract some features. So first, if some filtering or some normalization will be required, so it comes under image preprocessing, and then we can extract some of that texture based features, and then we can create a feature vector, and that feature vector we can use for the classification. And that classification, because it will be a supervised type of classifier that we can apply here, some SVN model or decision tree model or a KNN model that we can apply. Now, another one is that CNN based classifier. So in the CNN based classifier, no need to extract the features. As I told you that directly we can give the input images. Okay, so in the previous one, we can see that in this one, what is the difference between that? We are extracting that features. Okay, we are extracting that features, and we are just finding that, creating that feature vector, and then we are giving that feature vector as an input to the machine learning model. But in the deep learning model, that is a CNN based model, it's a deep learning CNN based model, it will automatically extract the features. So no need to manually extract the features. Okay, so automatically we can give that various malware images and benign images, normal images. So it contains that various layers. If you are aware about the CNN model, then convolution layer, ReLU activation function, pooling layer, and then output layer, fully connected layer, and then fully pooling layer, and then fully connected layer, then output layer. So that it will be iterative process. With the help of that iterative process, it will extract that features, and it will just create a feature vector automatically. Okay. So one more step, that got vanished in this CNN based model. Okay, in the deep learning model, in the machine learning model, we have to extract that feature. So that is not needed here. It will automatically extract that. So here, yeah, that will go with that. Before that, just I will tell you that what authors they have used that. So various authors. So just I have seen that various papers, gone through that various papers from the 2018, and various authors they have used that various techniques, various deep learning models for the malware detection and classification. So this link already I have given. If you are interested, I'll share this PPT. You can use that. And some that recent paper, that 2023-2024 paper, they are using that NLP, okay, natural language processing, as well as deep learning model. So in the deep learning model, that LSTM, RNN, CNN, and then hybridization of machine learning model, stack ensemble model also they are using. Okay. So now we will go with that some hands-on session. So if you are you know about that, how we can open the Google Colab and all. So we can start with the Google Colab, and you can just what you can do that you can just download any malware data. Okay, malware data set from Kaggle or GitHub also it is available. Many authors they have already share their data set. Okay, if you want to create your own data set, so you have to go through that static and dynamic analysis, and you can extract that. But various malware data sets are already available. Okay, so you know that how you can open the Google Colab. Okay, so you just download that one file. That is a malware data. I have already downloaded that. Can you share with them, sir, or you can download it? You can download it. My screen is visible. Na? That screen is visible. Yes. No, sir. That. So I have to again share it. I think. Just. So online. Any doubt is there with the online participants? So you all also you can just download one malware data file from Kaggle. Then we can go with the hands-on session. Yeah. Okay. Thank you. So I'm just sharing my screen with that Google Colab. Any malware data set, any malware data set, you can just download it. all the some of the data set, the features will be different, number of features will be different, but all belongs to that, all contains a benign or malignant malware. Just Google it, malware data set in the Kaggle. Yeah, now it's visible. No? Mm. So, so it's visible to all of you, or anyway they have already joined. No? Okay. So first thing is that you can just mount your Google Drive. Okay, if it is available in the Google Drive, then you can mount it. Okay, or you can upload it from that your C drive, your D drive, or any other drive. So what is the command you can use that? Files dot upload. Okay. So first you can use this command from google.colab import file. So first one is that from google.colab import drive. So you're importing the drive. When you will import the drive, all the files that are in your Google Drive that you can access. Okay. But suppose you want your file is not in the Google Drive, it is there in that your other drive. Okay, then you can upload that with the help of this from google.colab import files. Okay, so when you click on this, it will ask you to upload the file. Okay, you can just click on this. It will ask you, you have already downloaded, just I'm waiting for that 2-3 minutes. I can wait. You can just download any malware file. It's this also I have downloaded from the Kaggle only. Many data sets are available because many authors they are working and they are just uploading in the Kaggle. So find that. It's fine. Okay. So everybody downloaded that. Okay. So you can just upload it by using this command google.colab import file. Okay. So again, it's a malware file that I have taken. It is a CSV file. It's a comma separated file. Okay. Now to use that some data analysis part, okay, just import that panda, import pandas as PD and import numpy as NP. Okay, I think this you might have done earlier also. You can import these two files, that PD, I mean pandas and then numpy. Okay, and then you have to read the CSV file. So what is the command that? Because we how we can read that CSV file by using this panda library, the read underscore CSV file that is there in that pandas library. So pd dot read underscore CSV and then give that name of your file. Maybe your name file name will be different. So here my file name is malware underscore data dot CSV. So what file you have stored? Either you can rename it as a malware underscore data. Fine. So there will not be any confusion. So whatever file you are using, just give that dot CSV and see the separator. Mine is that comma separated file. Maybe your may be vertical line separator. See that how that it is separated. Okay. Normally it's a comma separated or vertical line. Sometimes it is separated vertical lines. Just check that. And then you can give that separator as a comma. Fine. So, and how to run that? Everybody know that how to run this program? We can just execute it cell by cell. And just you can check that how many, what are the various features are there. Okay, just by you are just storing the data set, then use this data set dot head. So head file, what head command, what it will do that it will give the first 5 records. It will show the first 5 records. Suppose inside this head, suppose you will give 10. Okay, by default it will show you that 5 records only. But suppose you will write 10 or 20, then it will show you that first 10 records or first 20 records like that. So had it that how many first file, how many first records that you want to see. Okay, that is for that we can use. So then we'll see that various features are there. So here, because we have given the head command, so that's why only 5 rows are coming. And how many columns are there? 79 columns. So 79 columns means 79 features will be there, but one column will be a labeled column. That will be a label one. Okay, here one label is there. So here we can see that various features are there, and if you want to again know about all the full form and all, this link is there. So basically these files, this header are based on that PE file. So DOS, in this link, that full form of each of the features are given. Okay. That is a DOS header.html, that is a gidra.re. So in this documentation, they have given this. Fine. So as that head, we can see the first 5. What will the user tell? TALIL tell? The last 5 records we can see. Okay. So you can just check that what is the last 5 record contains. So dataset dot tell. So suppose you will give that simply tell, then it will give you the last 5 records. But suppose you will write the dataset dot tell within that bracket, you will write 10. So it will show you that last 10 records. So last row you are doing or not? Your last row? Okay. So how many features are there in your file? It may be different file. How many features are there? How many columns are there in your file? 79. Yes. Maybe your file may be different. Just a minute, I will check that. You have got same file? Okay, different file, no problem. No problem, sir. What is the error? You have not yet uploaded, na? That I have given, na? That you have, okay, this. No, no, no. That file, you have not imported that. That command, you missed that. Just a minute, just a minute. I'm showing that. This one, either you can upload in the Google Drive or you can just write it from google.colab import files. I think this you have missed that. From google.colab import files. So here that uploaded equal to files.upload. I think this command you missed. Done? Okay. So just check that number of records from the header side and tell side. Yes. You downloaded it? No, no. From Kaggle you download, okay? Go to Kaggle, Kaggle. Kaggle website is there, na? Okay. Um, mm, mm. This is the Kaggle, okay? Kaggle, it's lots of repositories are there. Fine. When you'll go there, you will get that various data set. So you'll click on this. You will search that malware data set. Okay. Malware data set. Okay. So various that Android malware data set, many malware data. Okay. This is a malware detection data set. Now what you can do that from here you can download it. Okay. This is Android malware, no problem. Anyone. This is download. Okay. You have to sign it with your email ID, then it will get downloaded. Fine. It will be a zip file. You have to extract that file. Okay. Now you are able to read that. Yeah, it's fine. Yeah. Now you have to read that. Now you have already imported, and then yeah. Now you can read with that pd dot read CSV file. That just click on that. This command, this will not be needed. Simply you have zipped it or unzipped it, not. No, no, you have to unzip it. Okay, zip file we cannot. This is a CSV file, na? Just unzip it and store in that some CSV file. I mean, in some drive. Just unzip it. Zip file we cannot give. Fine. Unzip it. Yeah, you can extract it. I think you already extracted. What is that? I think it's open one. You already extracted, but it is so. Oh, where is your down? I think you have not downloaded. Just go to that Kaggle one again. This one? No. This one. No? I think you have executed wrong. You have downloaded wrong file. 24 KB will not be possible. Okay. Just go to that Kaggle. You have downloaded wrong file, I think. Just type that KAGGLE. Yeah, Kaggle. Okay. Kaggle dataset. Okay. Here, when we'll click on this, that various datasets are available. You can simply type here malware dataset. Okay. Just press enter. So here we can see that various malware datasets are available. Okay. So any one of the data like benign and malicious PE file that we are discussing now. So this you can click on this. Okay, just click on this download. Fine. Download dataset. So it will ask you for the sign in with your email ID. Okay, just if you write your email ID and you can just click on the forward password. Then it will give you a link to set the password. Okay. You've done that? Okay. Done. Okay. Yes. Yes. You have Google or Gmail ID you have, na? Gmail ID you can use. No. Actually, it is asking, na? Sign in with Kaggle. Okay. Just continue. Uh, Register with. No. Yeah. Just it ask. Just write your email and all this. You can register yourself. Fine. So that in future also you can use this Kaggle to download the files. Fine. It is not taking, then you can sign it, no problem. You can sign it in Kaggle. Okay. Here. Just it will ask you some questions. Okay. Just or yeah, just write your name and all. Okay. Done? You can just, what is that? You can go for registration. I think you people have not yet registered, no? Yeah, register it first. Okay. Once you will register, every time it will ask you for that username and password. You have not yet registered, no? Okay, no problem. You can register it. It will verify your email ID. Okay. Then you can set your password and all. Done? You have done registration? Yes, done. Huh? Username is already taken, no problem. Okay. No problem. Then go to the next one. Huh? It's not moving. Okay. So you can just you can use that. Just search it. Malware dataset. Okay, just click on that. Okay. Username is already taken. What is the problem then? You can just change that username, full name, and you can just this give one. Okay. It is not taking. You've already created that earlier. Then you can just register with a different name. Okay, but email ID will be same. Na? It will. Yes. Done. Unzip that file. Yeah. Yeah, here only you can unzip or in some drive. Here that D drive something will be there. Na? There you can unzip it. They have already done. What's the problem with you? You have any other? Uh, just sign it with the Google. Okay. Just take your email ID you take. Okay. This is an email ID. Just give that forgot password. Yeah, forgot password. Okay. It will come. Just send your give your email ID. It will send you link in your email ID. Okay. There you can reset the password. Okay. Just check your mail. It will give you the code. Okay. Fine. Done. This is actually they have already divided into two part. One is for training and another was the any one of the data set. First one you can use. Okay. No, it's coming. Yeah. Yeah. Uh, path is not needed. Once you'll upload it, na, it will take it. Directly it will take it. Okay. Once it will be uploaded. Okay. Then this simply you can give that without, when we'll upload it in the content folder, na, that time you have to give that content. Okay. So suppose you are uploading directly to this Google Colab. Okay. So that time this path is not needed. Directly you can give that data set name. It's clear? Okay. Otherwise you can just import, upload it here. Okay. This one, when you'll upload it, that time you have to give that here, this path you have to give. Fine. You can just copy the path and you can paste it. Fine. Yeah, that is also fine. No problem. Okay. Okay. So done. So your registration happen or not? He doesn't have Kaggle account actually. It's you're not received, man. Okay, but why? Sometimes actually because of the network. Just refresh it here. That network is there or not? Maybe after some time you can just check because they have already done. Just now they have registered. Okay, just check that how many features are there. Dataset dot head. Simply you. Huh? That? Okay. There's some more commands. Some. Yeah. Okay. Yeah. 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 We'll go that. What is the time? Hmm. Okay. So after that, you can again check for some more information that what are the column names? That is a feature name. What are the various features are there? What is their names? Okay. So simply type the dataset dot columns. So it will give you that the different feature name. Okay. Column names or feature names, you can say. Okay. Hello. Yeah. Done. Okay. After that, you can just check for the information. What are the different types of data is there? So it will give you that information about whole data set. So dataset dot info. Okay, dataset dot info. So all these are very common. Okay, all these are common commands that you can execute for your other machine learning programs also. Okay. Now you can see that how many. So here one column is there, that is a malware column. In that malware column, it's a labeled one. Okay. Here malware column is given. So all the files having malware, the value will be 1. All the files having that, all the normal files, the malware value will be 0. Okay. So just check in your file which one is a labeled one. Maybe sometimes it may be given as a legitimate or malware. Just check that which is representing that malware, I mean label of that data set. In my case, that label is malware. Okay. In your case, which one is the label? Just check it. It's voice is coming. Sir? Okay. And how many malwares are there? When you write the dataset malware dot value underscore count. So just check that which column is representing that label column. In your file, maybe label column may be different. Okay. Just see that column name. That's why I told you, na. Just see the column name. This is different file. I think it's a different file, not numeric value and all. Just download some. Huh? No, no, it must be there. Daughter.csv. No? Yeah, here we can see that. Just not to that one. Just go to the column name. Sometimes it is there only. No. This is the class. Actually, it's a multi-label. Your file is a multi-label, not mine is a binary one, that is a 1 and 0. Here is a multi-label. So I think 9 classes are there. So in the 9 classes, 2 represent that some second class. Okay, and that one represent that. So this one last one is a label one. It's a multi-class data set. Okay, what is yours? Yes. You can just check that df dot columns. Na? Here you can see that which one will be that labeled one. Access type device file. Any binary value? Yeah, this is the class. Na? This class. This class is a 1 or 0. Your is binary file. So B stands for benign and M stands for uh, S is for that malignant. Okay. So two types are there, S and B. Okay. So you can just check that what is your label name. Done? Yeah, it's fine. Okay, good. So now what we can, you can just check that how many are malware, how many files belongs to one class and how many files belongs to zero class. So what you can do that, data set within double quote, that column name where that it is representing the label, and then dot value underscore count and then bracket. Okay. This you can plot it as a pie chart also. Okay, so how we can plot it? Simply just import that matplotlib.py plot as PLT. Okay, and then you can plot this count. Okay, just import this matplotlib.py plot as PLT, and then you can count that label and you can plot it. Okay, that value underscore count dot plot, that your type of plot is pie, so it will give you that pie chart, pie plot. Okay, so here you can see that 74.4% data is malignant and only 25.6% data is benign. So the data is not balanced. Okay, for machine learning model, the data must be balanced. Both class of data must be equal. Okay, there should not be much difference. Otherwise, you will not get good result. That your machine learning model will be biased. Okay, but actually that example that I have taken, it's unbalanced one. So plotting done. Yes. Just I don't know which file you're downloaded. Yeah. Oh, so your file is that 63% is your malignant one and 37% is benign one. Yes, very good. Okay. This side, okay, everybody has done plotting. Your data is more unbalanced data. But here is, I think, multi-class, not a single class. How many are there? 88%. So only two, it contains 3 class of malware. Okay, not 2 class. Okay. When you'll see the label, there will be multi-classes will be there. Okay. So till now, there is no problem. Everybody has done. Okay. Now, next one is that after this, we have to just split our data set for training and testing. Okay. One more thing is that your class label, that your data set contains class label. Okay, in my case, my class label is malware. So that we have to drop from data set. Okay, because this malware, this will be a labeled one. So just create 2 vector. One will be X, in which your that features will get stored, and another one is that label. So Y will store the label one, and this we have to just drop the name of the that malware files. First column is name, na, that is not a numerical value. Then we can drop that name and then malware column. So 2 columns you have to drop it. Okay, so how we can drop that? Dataset dot drop within this is small bracket. Just give that name, that will be separated with comma, dot values. So these 2 values you have to drop from your file. Okay, and just store this malware values into Y.
So because this name and name is not a numerical value. Name of malware files are given, that is not a numerical value. That we have to drop it. Just see the column name. What is the name of that column? In my case, the column name is name only. And label, data label is malware. Name of the data label is malware. So that you have to drop it. Okay. So after that, we have to split our data set into training and testing with the help of this trend test split command. So for that, you have to import this from sklearn.model selection, you have to import that train test split. This file you have to import it. Okay. So what is X here? X is our feature set, and what is Y here? Y is a label. Okay. Okay, yeah. So this I can share with you. Okay, this code and this Google Colab file, and you can just run it after that. Okay, because there's we have a time restriction. Okay, so I don't know that online participants what they have done. I hope that they might have done something. So I will share this with all of you. Okay, so that you can refer it again. Right? Okay, so thank you so much for your patience. Thanks a lot. Okay. So, can I stop sharing?
Some time for doubts. Offline participants, if you have any doubts, just ask. Okay, over to the online participants. If you have any doubts, you can just unmute and ask.
Yes.
You have doubt. Okay.
Sir. Fine. Okay, there.
Ma'am, like, ma'am, doubt is like, if you're a hacker, ma'am, you sent me an image with an executable file. I have downloaded it. Just I have opened it. Does my system get infected or affected?
Yes, it will depend upon the nature of your that file. Okay.
Okay.
What kind of file is there? What kind of malware is there? Okay, so if obviously that if email will be there, so obviously there must be some virus. Nowadays they are sending through that email attachment. So obviously your system will get affected.
Just by opening it.
Yeah.
Okay, ma'am. Ma'am, another doubt is like, you have mentioned like using machine learning, log files and or log file malware can be. What purpose?
That again is a feature we can use those log files.
Does it change the logs inside?
Yeah. They can that when we'll execute that one or that malware will get in our system, na. So various log file will be there that we can use as a feature. Apart from this static and the dynamic feature, that will be another one that we can use. So one review paper I have given you. In that review paper, it is given all the things in detail. So if you're interested one, you can go through that. Many authors, they have used log file also as a feature one. Okay. So that will be very much interesting. Fine. So, but log collection, again, it's a task for the data collection. So data collection is a challenging task for the machine learning techniques. Okay. And that too a label data, and label must be correct one. Okay. That is a challenge. Okay. Thank you, sir.
One more doubt, ma'am.
Yes.
If you're considering that log files as a feature, then what is the key value we are choosing to analyze log files, ma'am? Like there would be like activity ID or some specific.
Yeah, many is time stamp, that process ID, and then various other features are there in the log file, system logs and our process log file. So all those we have to consider it. And then in the machine learning model, what you can do that you can just extract all those features, and by using all those features, first you can train our model and you can see the accuracy. Okay, and suppose you will see that what will be the prominent features, then we can go for the feature selection technique. So with the help of feature selection techniques, again, we can see the accuracy. So model training is also very much important. So the challenging task of the machine learning model is our label data must be correct. Second thing is that we have to select that feature very carefully. Okay, and after that carefully feature selection, so various feature selection techniques are there. So what we can do, the forward feature selection. So what we can do in the forward feature selection. First, we can train our model with all the features first. Okay, and then we can eliminate the features one by one. But suppose, for example, 10 features are there. So first we'll train our model with all the 10 features and we'll see the accuracy. What is the accuracy? And then you will eliminate one of the features. Okay, and then 9 features, suppose you will use, and again you will train the model and you can see the accuracy. So various feature selection techniques are there, backward, forward, various principal component analysis are there. So we have to analyze it while training. So once you will see that, yes, our model is trained perfectly, then we can go for the testing part. So model training, feature selection, all these are feature normalization, all these are very much important steps that in machine learning models we have to follow.
What is the effective algorithm or model for like selecting feature, ma'am? We have like decision trees and many models are there.
Yeah. So actually that PCA, it's a proven itself, the principal component analysis. It's a proven ICA, PCA, all these are very important. I mean, very popular and good also that you can implement. Any other?
ഇങ്ങനെ വീഡിയോ കാണിച്ചു തരാനൊക്കെ ഇങ്ങനെ വെറുതെ ആവശ്യമുണ്ടോ? എല്ലാതും മനസ്സിലാവുണ്ടോ ഇങ്ങനെ ഓഡിയോയിൽ പോയിട്ട്?
Yes, unmuted. Okay.
Any more doubts you can ask now? No doubts.
Okay. Okay, thank you so much.
We extend our heartfelt thanks to Dr. Kanchan Lata Kashyap for the insightful and enriching session on malware detection using machine learning techniques. The session shed valuable light on the applications of machine learning in strengthening cybersecurity, and we are truly grateful for your time and expertise, ma'am. Now, with that, we have come to the conclusion of the technical sessions of our 1 week FTP. Next, we move on to much awaited validation, which will be held at sharp 3:45. I warmly welcome all dignitaries, resource persons, participants, and guests to join us as we reflect on the achievements of this wonderful program and bring it to a successful close. Okay, thank you. Our 1 week workshop on secure cloud AI distributed systems organized by the Department of CSE Cybersecurity in association with SCADS Lab and the ACM Student Chapter IIIT Kottayam. To begin with this auspicious occasion, let's invoke the blessings of the Almighty with a prayer song. I request everyone to kindly rise for the prayer.
ഇങ്ങുമിങ്ങും നിറയും വെളിച്ചമേ ഇൻ മനസ്സിൽ കുടിയിരിക്കണമേ എന്റെ പാദം ഇടറാതിരിക്കുവാൻ ഇന്നും എന്നിൽ ദയ ചൊരിയണമേ നല്ല ചിന്തയായി എൻ്റെ മനസ്സിലും നല്ല ഭാഷയായി നാവിൻ്റെ തുമ്പിലും നല്ല ചെയ്തിയാൽ എൻ്റെ കരത്തിലും നന്മയാം നീ കടന്നിരിക്കണമേ. to officially welcome you all, I now invite Dr. Jobin Jose, Assistant Professor, to deliver the welcome address.
Respected dignitaries on and off the dais. Good afternoon, everyone present over here. So it gives me immense pleasure to welcome you for the World Peace ceremony of the 1 week FDP workshop on distributed secure cloud computing, AI, and distributed systems. So on behalf of everyone present here, let me do the duty which is entrusted to me. So, for over the past 1 week, we'll be witnessing a tremendous session or a tremendous participation from various parts of the states as well as from outside the states as well. So participants has shown a lot of enthusiasm in bringing up their ideas, sharing the knowledge, and interact with the public resource persons. And the resource persons are also enthusiastic in sharing their knowledge as well. So first and foremost, I would like to welcome all to this particular valedictory ceremony, especially the chief guest of today, Dr. Jameson Matthew, Professor IIT partner, who has consented to be the chief guest for today's valedictory ceremony. We welcome you, sir. Next, I would like to welcome our Associate Dean, Academic Affairs, Dr. Ebin Deni Raj, whose academic leadership and continuous encouragement fueled the innovation and research at IIT Kottayam. Welcome you, sir. Next, I would like to welcome Dr. Panchami V, our HOD of CSC Cybersecurity Department, for encouraging this to conduct this initiative and constant support throughout towards the success of this particular event. Welcome, ma'am. I warmly welcome all the head of the departments, faculty in charges, and all the faculty members for this particular function. And also, I would like to welcome other faculty members, the resource persons, especially for this particular FDP, and the technical and non-technical staffs, research scholars to this function. Welcome you all. And last but not the least, I would like to welcome all the participants who has attended this particular FDP, both online and offline, and who actually asks a lot of doubts and clarifies that or clarifies their now doubts with resource persons and all. Welcome you all for this particular function. Once again, thank you all, and I also welcome all people who are gathered both offline and online to this particular function. Thank you.
Thank you so much, sir, for your warm and gracious welcome. Next, I am honored to invite Dr. Ebin Deni Raj, Associate Dean, Academic Affairs, to deliver the valedictory address.
Good evening, all. It's really a pleasure to see all of you for this valedictory function. And also, while going through the schedule of this particular workshop, I'm quite impressed with all the different topics that is covered. And right from like cryptography, IoT, federated learning, then ML, AI, like you have flavors of all the various domains which are really required for progressing forward. So definitely for all the participants, I understand that around 5 or 6 they were staying in campus for the last 5 days. I'm sure for all of you, it would have been a really great experience, a different experience. And also let me remind you, maybe a session would have lasted for 1 to 2 hours only, and you would have got some glimpses or maybe some understanding of what the topic is about. So maybe like it is only a beginning. So you can spend time and again get in touch with the resource person or the concerned faculty I'm sure all of them will be definitely willing to help you if you want to pursue as a research or maybe as a project, whatever it be. So definitely make use of that, and also uh, always make sure that you come back for the next event, whatever that is organized by IIIT Kottayam. So as far as IIIT Kottayam is concerned, we are relatively newer institute, but we ensure that whatever we do, it aligns with the industry. So even in the schedule also, I can see there are at least a couple of industry resource persons. So you have the balance of both academia and industry in this as well. So I wish you all the very best, and thank you.
Thank you, sir, for your inspiring words and continued support throughout this FTP.
Yes. Jimson Matthew, HP. My machine somehow got it. Yeah.
We are privileged to have with us Dr. Jimson Matthew, professor at IIT Patna, to deliver the keynote address. So may I invite you to enlighten us with your words.
Am I audible?
Yes, sir, but speak.
Is it better?
So you're audible, but the voice is lower.
I don't know.
So 1 second, okay? Sir,
Maybe it's not connected to the.
Yes, sir. Now you're audible.
Okay. A very good evening to one and all. Dr. Jobin Jose, Dr. Ebin Raj, and HOD CSE, Dr. Panchami, and the coordinator celebration. At the outset, I would like to thank Dr. Celebration for inviting me for this quality function. So as you might experience last week, the important topics like clouds, secure cloud, AI, and distributed systems. So three important verticals are covered in this 1 week workshop. So when it comes to any systems, security is one of the most important part when it is private cloud or public cloud, on-premise or on the cloud systems. Security is important topics. I see a wide range of important topics are covered, right from encryption and all the topics you've already experienced. And also when it comes to AI, now we are living in a world of generative AI where foundational models are very important. So all the applications are now going through a revolutionary changes based on foundational models that we already seen. And when it comes to distributed systems, already you have seen some topics like federated learning, which is also very important when it comes to distributed learning, and at the same time fault tolerance. So I think these topics are already taught. I do not want to elaborate on this. You may be knowing better in this at this juncture. And IIIT Kottayam, I'm impressed that wide range of programs and conferences, workshops are being regularly organized at IIIT Kottayam. And I personally visited some time back Dr. Radhakrishnan. I met last time, and then most of the faculties also I am familiar. So once again, I thank Dr. Panchami, Jobin Jose, Ebin Raj, and Dr. Lempression for organizing this wonderful workshop. And I'm sure all the participants might have learned enough with some hands-on experience, I believe. And with these short words, I wish you all the best for future interviews. Thank you very much.
Thank you, sir, for your insightful and thoughtful provoking address. We are truly enriched. Now we move on to the certificate distribution segment. I'd like to invite Dr. Eben sir to the stage to kindly present the certificates and tokens of appreciation to our esteemed resource persons. First, I would like to call Dr. Reno Mary Daniel. Ma'am. Thank you, ma'am. Next, Gautam Malish, sir. Dr. Gautam Malish. Thank you, sir. Next, I'd like to welcome Dr. Amit Kumar Roy. Thank you, sir. Next, I'd like to welcome Dr. Panchami V. Next, I would like to welcome Dr. Atira. Thank you, Eben sir. Now I'd like to call Lindsay ma'am to come forward to just give away our present tokens and certificates to our resource persons. I would like to welcome Dr. Venkateshwaran. Okay, into his absence. Next, I'd like to welcome Dr. John Paul Martin. Not there. Okay, sir. Dr. Balu. Okay, so happy. Thank you, sir. Next, I'd like to welcome Ms. Mahima Matthews. I would like to welcome Dr. Kopala Guruvaya, sir. Thank you, Lindsay, ma'am. No, ma'am, please. Next, I'd like to welcome Dr. Lavanya Sitlapalli. Like to welcome HOD Panchmi ma'am to distribute the memento. Dr. Akash Nair. Dr. Kanchan Lata Kashyap. Thank you, ma'am. Thank you, ma'am. Next, we are moving on to the certificate distribution of our dear participants. Please come according to the order. Santosh, we'll welcome Eben sir to distribute the participant certificates. Santosh Kumar. Sai Shashank. Nitin Kumar. Thank you, Ibn sir. Next, I'd like to welcome Dr. Balu sir to distribute the participant certificates. Dr. Fasila K. Chelsea Paulos. Miss Amala Matthew. Miss Anne Prida Jose. Thank you. Thank you, Balu sir. Next, I'd like to call Amit sir to distribute the certificates. My name. It's myself first. Jumna A. Miss Jumna A. Maria Thomas. Thank you, sir. Next, I'd like to call Jay Ganesh sir to distribute the remaining. Sonia R. A. Devendran. Dr. B. Shanmugapriya. Thank you, sir. Next, I'd like to welcome our Eben sir for distributing the mementos for our dear coordinators who was working tirelessly behind this FTP. Okay. First, I'd like to welcome Silambarasan sir. Dr. E. Silambarasan. Next, I'd like to welcome Dr. Jobin Jose, coordinator.
Feedback. All the participants for feedback.
Okay, now we are opening a new session for the open feedbacks. We welcome any of the participants who were here with us for the last 5 days. You may use the stage now to bring out some insights or anything which you have gained from this session. Like it will help us to come.
Good evening, everyone. I am a second year BTech student from Bharatidas University. This faculty development program, I want to share my opinion and my experience. Every professors are very friendly And this program was very engaging and interesting. And as well, I learned many things theoretically as well as hands-on practice based on hands-on. Um, uh, I got a wide exposure of tools and many latest trends on cyber security. This was a great start for me. This is my experience here. Thank you.
Any other participants?
Good evening, everyone. Myself, R. Santosh Kumar, final year M.Tech from Balasan Institute, Tiruchirappalli. First of all, I want to thank everybody faculty members who has enriches ourselves with a good knowledge of present current trends in secure cloud, AI, and distributed system. So my experience from this FDB is that we have something around a limited amount of knowledge while we are first day in this means in this FDB. Now we have more number of knowledge, more amount of information, some research question will help us to enrich in our future. And thank you all who have supported and given opportunity to participate in the FDB. Thank you.
Any other feedback?
Good evening to everyone. I'm Dr. Shanmupriya from National Engineering College, Tamil Nadu. First of all, I would like to appreciate the team for this successful event, as well as all the experts are giving real-time examples and the research challenges. That was a very informative, as well as it is a wide spread of knowledge I gain, I think so. Before coming to this FTP, I was thought I was a bit good in cyber security, but I'm learning so much of new things like Hachi, FL, and so much of many topics are new to me. Thank to the team. I'm looking forward for further workshops also. Thank you.
To formally conclude the proceedings, I invite Dr. Silambarasan, Assistant Professor, to deliver the vote of thanks.
Good evening to one and all gathered here. As we come to the conclusion of 1 week FTP workshop on secure cloud, artificial intelligence, and distributed system, I take great pride and joy in delivering the vote of thanks. First of all, I should thank our director, sir, Dr. Prashad Krishna, sir, for his unwavering support and visionary leadership. And we also express our sincere thanks to our respected registrar, sir, Dr. Radhakrishnan, sir, in his and his administrative guidance and steadfast backing, which played a key role in the smooth execution of this FTP. I would also like to thank our esteemed chief guest, Dr. Jimson Matthews, sir, IIT Patna. In the short period, he accepted my invitation. He gave the keynote address. Our heartfelt appreciation goes to Professor in charge, Mohanan, sir, and the chief guest of today, or we can say that we have to thank our Ebin Daniel Raj, sir. And a special thanks to HOD ma'am, Panjami, for her vision, encouragement, and nurturing a culture of research and innovation within our department. We are also thankful to all the various departments, and our heartfelt gratitude to all the resource persons for graciously sharing your expertise and initiating thought-provoking discussions. A special and heartfelt thank you to all the faculty members, researchers, participants from various places, various universities, and from our institute also. your active involvement and insightful questions, right? It makes more impactful. As I conclude, let me remind you, this is not end of our journey. It is only the beginning. Let us carry forward the spirit of inquiry and collaborations that we have nurtured here and transform it into enduring the academic partnerships and meaningful research outcomes. Thank you once again.